Hello everyone, I am Sagar Bilare. I have 7 years of experience in training for data science, machine learning and artificial intelligence. I have completed my masters in AI. Today we are going to learn about Python programming. In this module we will try to understand the basics of Python programming, what are the language constructs and what are the grammars of Python programming. So now we will try to understand in depth of the topic. So at the end of the session, we will try to understand different constructs with respect to Python. We'll get introduced to the history of Python, the applications of Python programming, how to create variables and what are different types of variables. We'll try to understand functions in depth. We'll understand operators and different types of operators. At the same time, we will understand Python flow controls, implement conditional statements and implement loops in Python. So let us start with the first construct, that is history of Python. So this session is Python, entirely focused on Python. So as we are getting introduced to a new topic, so this new topic will have its own set of grammars and rules. So we have to follow all these grammars and rules. So in this entire series of session, we will try to understand the set of rules and principles, how we can write code in Python, how we can make the machine understand our area of we will make the machine understand different instructions that we want to pass inside the machine. So history of Python. Python has a very interesting history. It was invented in December 1989 and it was publicly released in 1991. It is said to be an open source programming language and it was managed by Python's Software Foundation. The person who actually invented Python is Guido van Rossum, and there is an interesting story behind naming this program as this programming language as Python. The person Guido van Rossum actually was interested or was a fan of a show called as Monty Python, and there is the name of this programming language also came out of that same show, which is a Monty Python show, and that is why it is called as Python. Python is a very interesting language. It is powerful programming language. At the same time, it is open source. That's why most of the people who are into programming prefer Python. So let us try to understand in detail about the Python programming language. As I said, Python is a powerful and fast programming language. It is very well synchronized with other tools, other data sources, other libraries, and it can run across different OS or operating systems. That is why it is kind of globally accepted as an open source programming language. At the same time, Python is very easy and friendly. Anyone who is a beginner who wants to learn programming can start with Python as their language of programming. And as I said, it is an open source programming language, so it is free. We do not have to pay anything. Now, Python is said to be an interpreted language and it is not a compiled language. So if we talk about other programming languages, so we have to compile the instructions that we want to send to the machine first. This compiled version of our code will be set into the machine, and now the machine will decode the compiled version of our code. But in Python we do not have to do that. So that is the best part, because if we want to retrace an error, the compiled version of programming becomes difficult to get and understand the error. So Python serves as a language which helps us in understanding the code, and as it is an interpreted language, so all the instructions and errors can be easily understood there and there itself. Python is said to be a high-level programming language, which means a programmer can focus on what to do instead of how to do. Now, when we talk about high level languages, there are different high level languages, which is talking about how and what kind of instruction we want to pass in. There are two types of languages, high level language and low level language. High level languages basically are the languages where we pass in instructions into that particular language. But when we talk about the low level languages, these are machine languages. So it involves physical interactions with the machine. So these are very much lower level codes, binary codes. So Python is a high level language where we can pass simple instructions and get the output. Whereas the low level language involves giving the code in a form of binary instructions, which is difficult for humans to pass in that information. So that's why it is a very interesting language, very easy to use language. Now, writing programs in Python takes very less time than in other programming languages, because Python doesn't have a complex architecture of codes. It has a very simple codes which are kind of very much familiar, like very much familiar words we are using in Python. We are using normal English sometimes, and that's why it becomes easy. Whereas in other codes, there are complex architecture, there are complex set of instructions that we need to keep on passing. And even if a single element of that code is missed out, you will get errors. But when it comes to Python, the instructions are quite clear. These are cleaner set of codes that you have to pass. We will come to know in detail in the upcoming slides. Now, Python, as we said, it is a programming language. The inspiration of Python comes from different other programming languages. Like we have the C programming language, which is kind of the very oldest set of programming language. Then we have Java, Perl, ISP and C++. Retake. Python drew its inspiration from different programming languages like C, Java, C++, Perl, etc. All these programming languages set out a set of commands given in these programming languages are kind of very much complex. So the developers or the person who developed the Python took into consideration how we can minimize the complexity of setting codes in Python programming language. Now let us try to understand where is Python used. As I said, Python is a versatile tool and a very easy to use tool. That's why lot of programmers, lot of developers and people around different industry are using Python. So it is used in mobile applications, developing mobile applications. As we are using different mobile applications, we use Python there. It is used in game development, because nowadays there is a kind of trend in game development. There are a lot of games developed. It is a huge industry. It is also used in web programming, like developing websites. It is also used to generate a set of interface between the databases as well as the front end of a website. So it works as a back-end support sometimes. It is used in GUI development. For example, if you are creating a graphical user interface, any softwares. It is more specifically used in data science because it supports different sets of library which are easy to handle and very powerful. It can give us real-time analysis of data efficiently. It is used in data engineering, where we want to store the data, source the data from different sources and kind of retrieve that data in a faster way. So Python can be the language, or it is most widely used in data engineering as well to construct new databases. It is used as system administrator language. So when we talk about system administrator, it is used in automating stuff. Okay, it requires different set of instruction, different sets of library which are easily used in system architecture or system administrator. It is also used in networking or creating networks. So using Python, we can use network programming, we can use it in network programming, as it is a very easy to go tool. That's why many industries or many sectors or many development areas prefer this programming language. Now let us try to understand the difference between compiling and interpreting. So as I said earlier, so there are two types of languages. The one in which we compile things, and the other one where we interpret. So there is a body of compiler, there is a body of interpreter. So there are certain languages like Java which needs to be compiled first. Now what is compiling a language? So compiling means we convert the instructions that we want to give them to the machine. So instructions that we are going to pass are going to be in a form of a code. These codes are interpreted in a machine language, and it can be interpreted as a byte code. These byte code are now being interpreted as a instruction to the machine in the low level programming language. So compiling and interpreting is an element of writing a smoother code and getting it executed. So Java uses this compiling and interpreting approach, where we have to first create a compiler code and then we have to create a interpreter or interpret the code, the compiled version of code in a machine. But when it comes to Python, you simply write a code and it will directly be interpreted into machine language or machine instruction. That is why it is a very interesting language. Now there are different development environments on which Python can be hosted. So first and the foremost that we are going to talk about is terminal. Any languages, any programming tools, any softwares can be basically implemented through terminal. So terminal can be terminal or your command prompt, from which you can pass instructions to your machine. And Python, if you want to implement, you can set instructions from interpreter, your terminal, as well as command prompt. So you can execute the set of Python code using terminal or command prompt. So this is first development environment. It is a very basic development environment. Then we have different IDEs or integrated development environments like Spider. Spider is a development environment where we can save the data or save the Python code as .py. It is a set of instruction given in a kind of textual script, and as these instructions are passed inside this code, it can be executed in a single go. So this .py file, which is developed using Spider, can act as a single set of file and can be directly used as a program as well. Then we have IPython Jupyter Notebook or IPython Notebook, Jupyter Notebook. We have Google Colabs also. It is on the same lines. So what is a notebook? So notebook is a set of series of cells. In these cells we can write our Python code and it will be directly interpreted in the notebook itself. So whatever output we are trying to see, we will get in the notepad itself or the notebook itself. Instead, when we talk about Spider IDEs, the output will be drawn, or the output will be calculated, or whatever output we want to see will be shown on a separate interpreted versions or terminal. But when it comes to notebook, all the output will be given on the notebook itself. If you are a beginner and if you want to learn Python as a programming language, it is always recommended to go with notebook, because there you will be able to see the code as well as the output of that code in a single set of instructions. You do not have to go to or switch on to different windows. We can see the instructions and then we can make corrections in the instructions. So as a beginner, it is always recommended to start with notebook. Now we will talk about different or we will talk about the IDE or a platform where we can install this Jupyter notebook or our entire Python environment. Python can be directly installed from the Python website or the official Python website. You will get the latest version of Python there. If not, we can go with Anaconda, and Anaconda is the best way to start with your Python journey. If we are directly installing Python from the Python website, so it will open in usually in terminal or your command prompt. It is not recommended to directly start with command prompt because sometimes it becomes very difficult to handle Python over there, and the saving of code also becomes difficult. So it is always recommended to go with something such as IDE Spider or Jupyter notebook. So we will start understanding how we can start with the Jupyter notebook. So there is a website called anaconda.org. There you have to go and download the Anaconda distribution or Anaconda navigator. So Anaconda is a set of different tools. Anaconda has a set of different tools which are which have different programming languages which are related to data analysis, machine learning and all. So Anaconda navigator will have different tools, and we have to open or download that Anaconda navigator. So in Anaconda, as an Anaconda is a distribution or a navigator, as it will have different tools, it will also have Jupyter notebook, Spider, which is an IPython, which is essential for developing or writing scripts. We are going to start with Jupyter, and as we are talking about Python, we need some basic data analysis support also along with Python. So Python is our core language, and on top of our core language we require different data analysis support libraries. So these support libraries can be NumPy, Pandas, Matplotlib, Seaborn. All this combined version of support libraries can be put into we need to separately install if we are installing only the Python from the website. But when we are installing Anaconda, all of it will get installed in the single same package of Anaconda distribution or navigator. So we will download and install Anaconda navigator, and it will directly install all of the relevant data science libraries or packages, so as to minimize our effort on installation of these libraries separately. So this is what our Anaconda base environment. We have to install Anaconda base environment or Anaconda navigator. The interface of the Anaconda navigator, as we can see on the screen. So as I said, it has different options here. You can see home, you can see environments, projects, learning and community. Home is a place where you will see all the different websites or tools which are essential for doing data analysis, placed right in front of us. Starting with Jupyter Lab, then we have Jupyter Notebook, Qt Console, Spider, Bitwise, Orange and RT Studio or RStudio. We can also see more or less number of softwares or tools here, but Jupyter Notebook and Spider will be always there, and Jupyter Lab as well will be always there in this entire navigator. The applications are now hosted, or whatever code we are going to write are now hosted or using the root environment. So right now we are on the root. You can switch up environments using the environment sections, and you have different set of instructions here that you can see. If you want to learn or if you want to do some self-learning, so you can click on learning and you will get the official documentation of that website. For example, if you want to learn more about pandas, okay, so if you click on learning, it will give you instructions about pandas. If you want to learn about Python, so if you click on it, it will give you instructions about Python. So similarly, there are different channels and learning areas also which are getting installed along with this navigator. So this is our navigator interface. So what we need to do is we can launch either Jupyter Notebook or Spider to start with our Python programming journey. So we can start with Jupyter Notebook as our base tool. I will show you exactly how we have to work on this interface. So there are few things that we have to understand when it comes to Jupyter IDE. So on top of it, on a Jupyter IDE, we can see untitled written. So untitled basically is the space where we can write down our name of the file. Whatever is the name of the file, we can write it down. Then we have areas such as menu bar. On menu bar, we can see different file handling menu. For example, file, if you want to save this file, if you want to load some other file or something like that, you can handle it using file. You will have edit if you want to edit certain areas or certain files. You have view section, insert section. We will try to discuss each and everything in detail when we open our Jupyter Notebook. This is our menu bar. After this menu bar, we also see the execute the code using run button. So basically, this is our Python cell where we write our code. We can see the cell is in green color, which means right now it is able to interpret Python code. Okay, I will show you what exactly this actually means when we open it. And then we have Python 3 as our kernel. So kernel basically can be considered as a new environment or new space where we are writing our code. So here also we have Python 3 as our kernel, which is active. So this is our Jupyter IDE, and this is how a simple Python notebook looks like. We have different cells, and just below the cells, as you can see, there are the codes which are written. So these are our codes that we are writing out, and here we have the output of this code. This is our output. Again, here are certain instructions which are written, which are codes that we are passing in, and this is the output that we are getting after running that code. Okay, then similarly here also these are instructions, these are the output that we are getting. So this is how the IDE, a usual Jupyter Notebook, looks like when we start working on this Jupyter Notebook. So when you start with your Jupyter Notebook, it will also look like this only. Now there is a different IDE, that is Spider. As I told you, Spider or terminal, if we talk about, has two different sections. So this is our scripting section, okay, and this is our terminal or our IPython kernel. It is our kernel actually. So the area, the scripting area, where we can write down our set of instructions or code, and these instructions can be saved as .py file. Here, even in Jupyter Notebook, we can save a Jupyter Notebook, but it is not directly executable. If we talk about Jupyter Notebook, it is not directly executable as a independent program, but .py is an interpreted .py is a version which can be directly executed as an independent program. So this is our .py file. This is our scripting area. This will have, we will write all our codes here, and this set of codes can be run together as a single program. And as we write code, we can also see the output by using this run button. And this, when I use this run button, so it will, as you can see here, it will get executed. This is the execution area, and in this execution area, it will actually start showing the output, whatever errors and all. But if you see, this is our entire scripting area where we write, and this is a separate terminal or a kernel kind of being open just to see the execution part. Okay, so this is usually used by people who are into development kind of role. They are into kind of developing some softwares, some application, web applications or something like that. So if you are into development, we can kind of use this. But if you are more towards data side, where we are aligning or creating models, where we are creating machine learning models, so, and you want to test efficiently in a faster way, so Jupyter Notebook is the one that is easy going for someone who is into data analysis. And Spider is something which is for development side. If we have already written some codes in Jupyter Notebook, and now you want to use that entire set of instructions as a single program, you can convert that code into your .py file, and this can be entirely sent as a single instruction to the machine, and it can become a single program. So that is why we can kind of switch over this both of the platform. But if whatever you are writing and the Spider cannot be converted into Jupyter notebook, and whatever you are writing into Jupyter notebook can be converted into a Spider version. So that is the difference. So it's very easy going for a beginner to use and start with Jupyter notebook compared to Spider. When we start with development part, so you can actually start with the Spider. So here we will try to understand a simple code which is written, how exactly this code works. Okay, so we are not going to get into the entire details of this code. We are just trying to see what exactly happens when a code is written. Okay, so when, as you can see here, is a set of code x is equal to 34 minus 23, and after that code a hash sign is written, and we have written a comment. Okay, so the part which is before this hash sign is actually our code, and anything after this hash sign, symbol can be considered as a comment, which means our interpreter will not understand what exactly this or it will try to ignore whatever is written after this hash symbol. Similarly, you can see here also we have written code y is equal to hello, z is equal to 3.45. We can see some if condition, and all this set of instructions together kind of generate or become a program. Okay, we try to create program based on different level of conditions, different level of input output data. So this is how it works. So in order to assign something, if you want to assign something to someone, okay, so as we are assigning x the value 34 minus 23, so whatever is the output of 34 minus 23 is assigned to x using a single equal to operator. If you are using a single equal to operator, it is getting assigned. But if you are using double equal to operator, it becomes comparison. It is actually comparison. Comparison means it will see that the value on the left hand side and the value on the right hand side are same. If the value on left hand side and the value on right hand side are same, the output of this comparison becomes true, and or otherwise it will becomes false. So single equal to is used to assign some value, and double equal to is used to compare two entities together. Followed by that, you can also see different symbols like plus sign. This is used for handling numbers, like adding the numbers, minus sign to subtract the numbers. These are different kind of symbols which are used in order to these are different types of symbols which are also a part of our program. So it is not only about x or equal to or double equal to, we have symbols also to interact with this program. Then we have logical operators such as and, or not, that we will see. These are normal English words, but it has some meanings in our program. So these are also a part of our Python program. Then we have print, which is a function, basically a printing function. And now print is also a part of our Python program. X and Y and Z, these are variable, these are external things that we actually create. But print is also a part of Python program. And then we have hash, as we discussed, it converts everything as a comment which is written after that hash symbol. So now we will start with the actual implementation. We will see the interface of Anaconda Studio. We will see what are different types of options that are available to work on Python. So let us begin. So I have already installed this Anaconda Studio in my computer. So I will directly open it. You can search in your start menu, or if you have Mac, you can search it here in the spotlight area, and you can see Anaconda Navigator pops up. So we just have to open it. So if it is Windows, you can search in the start menu, and if it is Mac, you can search it in the Spotlight, you will get the Anaconda Navigator. So it is a very heavy software. Sometimes in some of the computers or laptops, it will take time to actually open up, like it takes time to open, but once you open it, it becomes very much fast. So this is our Anaconda Navigator, and in this navigator we can see different options. So we'll start with the home button. In the home button you can see all different set of applications. So if you want installed application, if you want not installed application, or updatable applications, all different set of applications are present here. Then we have base root, where you will find different environments. So these are set of environments that I have created, so you can create your own environment. Right now we are working on the base root, where we will start initially our basic programming or Python journey. Here we have channels, then we have softwares which are mentioned over here. All this tools, application, software, whatever we can call, to work on data. So data spell is one such that we have in the current version that I'm using. Then we have Anaconda notebooks. It is also there in the current version of this Anaconda Studio. Then we have Jupyter Lab, Jupyter Notebook, which kind of use Python as their base software. So Python is the base software. These are only the IDEs where we write our codes and see the output. Followed by that we have PyCharm Professional, that is a software. It is a different IDE altogether for development kind of environment. So PyCharm is there. Then we have Qt Console. Here also it is a kind of used for graphical, it is a GUI for Python related development. We have Spider, on which you can write your Python codes. Data Lore, IBM Watson Data Studio or Cloud Studio, Oracle Cloud Infrastructure, and Anaconda Toolbox, Bluewiz, Orange 3. These are different additional softwares which are actually helpful for doing data related work like visualization and all different type of work we can do over here. So now we will only start with our basic Python journey. So we are starting with a very fresh Python journey. So I will start with exploring the Spider environment first. Then we will start with Jupyter Notebook, on which we will start our coding part. So I will open this Spider here using this launch. So as you can see, this is my Spider console. On this console you can see here temp.py. This is a default file which gets open immediately when you open your Spider. Okay, here you can set your or write all the codes that you want to write, okay, or the instruction, Python instruction you can write. And if you want to run this instruction say a is equal to say 10, and if you want to run it, you can simply click on this run button and it will run. There are different run options, like if you want to run selection, run a single line, run multiple lines, all this different set of instructions are there. So run and debug, these also option is there. So this is usually for people who are into development, who want to develop softwares, web applications, APIs, anything like that. So this environment is very much helpful, because if you are developing a software or something, it has to be on a single file. So as we can see here, I have written a code as a is equal to 10, and if we just run this, I'll click on run, and you can see here in the console part, this is our console, IPy console. Actually this is this acts as a terminal. This is a terminal where the code is getting executed, and you can see run file, this entire file has been run. Okay, now if I want to see this file, I can write print a, it will give me what is this output of a, and I will again run it. So it will run both the lines now. A is equal to 10, and you can see the output a is equal to 10 is getting printed. Okay, you can write any message, like usually as we start in Python or any programming language, we start with hello world. So you can write hello, you can write hello world, and if you want to get this executed, you can simply run this. Now it will print, it will run all three statements. So I will just run it and see it is printing 10 and then it is printing hello world. So these are set of instructions that is kind of created. Now this spider actually has a very good advantage when we are working or in a development environment. So when we are working on a development environment, we may have to write 1000, 2000, 3000, sometimes 30-40,000 lines of code in a single notebook, so as to get it executed together. So when we are working on 10,000 lines, 2,000 lines, 5,000 lines, whatever number of lines of code together, so it becomes difficult to trace back different variables. So in Spider we have that kind of facility to kind of trace back our variable and what kind of value that variable is holding right now. So you can see a is the name of the variable that I have created. The type is integer, the size is 1, and the value that it is holding is 10. So these is a variable where you can just see different kind of things together. Okay, all the variables that you are going to generate will be listed down here. Then this Qt console actually tells us about the output, like it helps us run the output and see the output in here. And you have plots area if in case you are creating any charts or plots or visuals using Python. So these will be visible over here in the plot section. As soon as you run that code, automatically the plot we will get shifted to the plot section and the output will be visible here. Okay, immediately when you are running a plot. So we will see it later on when we are working on some advanced data analytics libraries. So right now this is how it actually is. This is the simple interface of Spider. If in case we are working on a development kind of role or development kind of environment, Spider is a very handy tool in a development kind of environment. So now I don't want to work on Spider. I have just introduced you Spider. You can just observe what exactly this Spider is. We'll shift back to our Anaconda studio, and on this Anaconda navigator we will now be going on this Jupyter notebook. I'll click on launch. So like we had Spider, when we launched this Spider actually opened in a as a software. It gets opened as a software, but Jupyter notebook will not open as a software. It will open as a web page in your any default browser. So whatever is your default browser, as you click on launch, it will get open in that default browser. And as you can see, it is getting open in this Chrome browser. I have Chrome as my default browser, so it is getting open like this. And there is one more important thing that gets opened when you click on the launch button. So when you are clicking on this launch button, this terminal gets opened. So this is your Jupyter Mac command prompt or terminal. If you are on Windows also, it will get open. So this is very important. Why? Because whatever you are going to write in your Jupyter notebook actually will be written or actually will get executed here line by line. You can see the progress when you are doing something over here. Some kind of reaction is also happening in this area. So if you close this, your Python connection is disabled or your Jupyter will not work. Okay, maybe in the upcoming versions it will work, but in the current version, as we can see, if I'm writing something, if I close this terminal and if I keep on writing something on this, if I keep on working on this, it will not get worked out, because this Jupyter notebook, whichever is open, is getting the kernel being running at this terminal or at this command prompt window. So do not close this if you are opening this Jupyter notebook. Keep it active as it is. Do not touch it. You can what you can do best is you can just minimize it, and you can start working on things that you are going to explore here. Okay, so this is my Jupyter notebook area home page. Now when I talk about Jupyter notebook homepage, so it actually gives me this kind of explorer. This is my home page or in explorer, and actually it is a tree data structure. You can see it is a tree of different folders. So as we can see, folders are in a tree structure only. Whenever the data is arranged in folder, it is actually in tree format only. So this is a base root environment. This is my base root. This is where my Anaconda is actually installed. in my C drive. These are all files of my C drive. You can see Anaconda 3, applications, desktop, documents, downloads, movies, music. All of these files are actually my C drive local files, and there are different files also I have here in my C drive. So in your case you may see different set of folders here depending on whatever files are present in your C drive. Okay, so this is my basic set of folders, and here I can choose any folder. If I click on it, you can see all the files within that within that folders are visible here. Okay, so if you click on applications, so I kind of navigate through all my folders also across here. So as I have this desktop, you can see in desktop I have different folders, different files. All files will be visible here, but it is not necessary that you can open all of the files. Okay, you can open Jupyter notebook files only. Okay, so here we can see a different set of files in my documents, in my downloads. In my downloads also I have different set of files. I will just randomly open any one Jupyter notebook file now, just to show you how exactly you have to open your Jupyter notebook file. Okay, so this is these are all folders that I have, and I have this books, notebooks. You can see the symbol is of notebook, and you can see the how when it was last modified, and what is the size of that file. Simply some kind of stats is given here for each of the file. So I will just open a random file. So this is my ANN regression. So when I click on this just a random file, so it actually opens like this. Some notebook interface is getting open, as you can see. So if I try to open this, suppose this file is right now in my downloads folder, and I want to open it directly through my downloads folder in my Explorer or Finder. So I will open my Finder or Explorer, and I'll go to my download section. I will try to open the same file or any Jupyter notebook file. Okay, I'll try to open any Jupyter notebook file directly. Let me search here any Jupyter notebook file. Yeah, so I have this data pre-processing file. Okay, in the download section I will right now just open that file here, and this is my data pre-processing file. I'll click on here. You can see this is how it opens. But if I try to open this Jupyter notebook file directly, so this is present in my folder also. So I'm going on my folders through Windows Explorer or Finder directly, and if I double click on it, let's see what happens. If I try to open it from here, so it is getting open in an environment. This is my Visual Studio. Actually it is getting opened in Visual Studio directly, but if you do not install Visual Studio, it will not open. It will not open, or it will ask you to open using a certain format. So if you directly click on this, double click on this, if Visual Studio is not installed or PyCharm is not installed, this will not get opened. Okay, so if you want to open any Jupyter notebook, all you have to do is you have to first open Jupyter notebook through your Anaconda navigator. First open it through navigator, and you have to go on downloads, and once you go on downloads, you can find out your file wherever it is present. Say it is in downloads, so you have to go and click on downloads. That file will get open in download. So whatever file you want to open in Jupyter notebook environment, this is the only way that you can go. In the upcoming versions maybe it will get open, but right now there is no facility as such to open it directly. Or you can click on, say if I'm opening this file, and if you want to open it, you can click on file and open, and yeah, you have this option where you can open it directly. So these are the only options which are there if you want to open a Jupyter notebook file which is already there into your system. Okay, now let us understand how to open a new file in Jupyter notebook. So in order to open a new file in Jupyter notebook, we need to first click on new, which is here on the top right section, and you have to click on Python 3 IPy Okay, you can create a new text file, you can create a new folder, you can create a new terminal window. So I am clicking on Python 3 IPy and as I click on ipykernel, a new file named as untitled 14 gets open, and this file is actually inside my downloads folder. Okay, so we have to understand that where this file is getting open. So I'm opening this file in my downloads. If you navigate on desktop, and when you are on desktop, right now we are in the desktop, and when you click on new and Python 3, this file will get open in desktop. See, this is getting open in desktop. So it depends where you are trying to open that file. You have to be present in that drive. Okay, so right now I am on the downloads section. I will disregard this file and I'll click on this untitled 14, and I'll call this file as my Python learning file. So this is my Python learning file, and as we have seen in the instructions how and exactly what kind of data is there in this Jupyter notebook. So how and what kind of instructions are there in this Jupyter notebook. So this is my Python learning name. This is name of the Jupyter notebook that I have given. The name of the notebook is Jupyter notebook. This Jupyter notebook now is present in my downloads folder. You can see Python learning ipynb. If you want to confirm it, you can see here the file has been created. So this is how a file is generated in Jupyter notebook. You can share this file as an attachment to anyone who wants to utilize or understand your code. So this is a shareable version of file. Now we will just rename, keep the name as it is, and let us try to understand what is happening in this Jupyter notebook. You can see it is written last checkpoint 2 minutes ago. So what is this checkpoint? Checkpoint is a so Jupyter notebook actually facilitates auto saving of your work, whatever you are writing. So say I'm writing a is equal to 10, so it will get auto saved. If you run it, it will get auto saved, which means whenever you are reopening that file, it will be there in the file. You don't have to explicitly save. If you want to save something as you consider as a checkpoint, you can click on save and checkpoint and you can do it. Okay, so by default there is an auto save features which is kind of enabled, and that is a very handy features. You do not have to save it manually, and your work you can rework on wherever you have left out, and that's a good part when it comes to Jupyter notebook. So it is very much friendly for a beginner, basically, because beginner already have this tendencies of making mistakes. So always it is recommended for a beginner. It is a very good and handy kind of approach which is given by this Jupyter notebook. Now we will discuss about this menu bar in detail, try to understand different aspects of this menu bar. So in this menu bar you can see the file section, and in the file section you can see new notebook, Python 3, which is ipykernel. So if you want to create a new notebook, you can create a new notebook. If you want to open a new existing file, the file Jupyter notebook is already there. If you want to open it, you can click on open, and it will take you back to this home page only once you click on open only. Okay, if you want to make a copy of this existing file, so you can click on make a copy. So automatically a file I'll show you like a copy of, so this is how it gets created, Python learning copy 1. Okay, so automatically a copy is kind of created. So I'm just removing it from here. Also it is getting created, so I have to remove it from here as well. I'll click on it, and the delete option, you can see it is already given here, delete, and it gets deleted. Okay, then we will click on so file. We have a lot of different options: save as, rename, save and checkpoint, and then we have revert to checkpoint. So if you want to revert to a checkpoint, so here is a checkpoint that was generated at Friday 20 September and 12:35, which is the today's date. So I can click on it and I can just go on that particular checkpoint, and you can click on print preview. If you want to print out and send this to someone as a PDF file or something, you can click over here and download as different versions. So whatever work you have done, if you want to download that work as a different set of format, you can have ASC2 code file or doc file or HTML file, or you want to save it as LaTeX, Markdown, Notebook, PDF via LaTeX, REST. These are all different set of files. So this Jupyter notebook can be converted into a different readable format. Okay, so wherever you can use it, you can use it. Okay, And then if you want to close and halt this Jupyter notebook, you can click on close and halt. This Jupyter notebook will get closed. So these are all set of options. We have different options while we are writing codes. When we are trying to write something over here, so we can use this edit option. So in this edit option, you have cut cells, then copy cells, then paste cells above, paste cell below. So what is cut cell? So this element, this green element, this entire thing is a cell. So if you want to cut this cell, you can directly click on edit and cut this cell. And if you want to paste it above or below, you can use this paste option. If you want to copy this cell and recreate it for some or reuse it for something else, you can copy this entire cell, this entire thing, this horizontal rectangle kind of field. You can just recreate or kind of create a copy of it. All different options are available, like delete, split the cell into multiple, merge cells above, like if you want to merge 2 to 3 cells, if you want to move the cells up and down, all these different options are available. Then you have view options. So if you want to toggle the header, toggle the toolbar, this also can be done. Okay, toggle line number, so this can be used. We will see exactly what this does in detail. If you want to insert new cells, you can click on insert cell above. If you want to create a cell above, you can click on it. A cell is getting inserted above. If you click on insert cell below, so it will create a cell below this cell. So that is an insert option. And when it comes to cell, a single cell, you can have different options. Like if you want to run all the cells, you can click on run cells. If you want to run cells and select something, run cells and insert below. All different options with respect to running a cell and observing options is also given. Then current outputs, if you want to toggle, or current option, if you want to toggle or toggle scroll the current options, these all options are also available. Now we'll talk about very important part, which is kernel. So kernel is a place where the code is getting run. So if you are writing anything, actually it is getting run in this minimized version of our terminal. Whatever we are writing, this is actually getting run on this kernel. So this is our kernel which is active, and that is the reason we are able to kind of work on this Jupyter notebook. So all the codes and instructions which are running on this kernel. So if you want to stop that kernel or interrupt it, you can use interrupt, or you can press I twice. If you want to restart, you can use 0 twice. All these options. So restarting a kernel is also available. Restart and clearing the output of a kernel is also available. You can run all the output also. And if you want to reconnect a kernel, sometimes what happens if you are running a very huge file, so kernel gets hang, or it kind of gets disconnected, so with the Python environment. So if in case that is happening, you want to reconnect, you can reconnect it. You want to shut down a kernel, that is also possible. And if you want to use a different kernel, so you can change the kernel and you can call it as a new kernel. So sometimes in a certain kernel, some libraries or some files are getting generated which are not quite handy. Or sometimes some variables are getting created which are not much useful. So you can simply switch, or some errors are continuously happening in your kernel. It is like you are having a it is like having a pen or something, or a mobile phone or something, in which continuously you are getting some kind of glitches and error. So if you want to make it as a new thing, so you kind of reformat it, remove all the data. So it is the same kind of approach when we create a new kernel. You can see different widgets also. These are some additional stuffs which are given, which are not quite used, and we will not try to focus on these areas as of. And help button basically is a very good thing. You can use the help button to understand and take, or if you want to learn more about this Jupyter notebook environment, shortcuts and part. So all different shortcuts are kind of given here, and this actually helps us out in real time scenarios when we are working on Jupyter notebook. So these are our menu bar. You can see this logout button. So this will log out you from this this session. This is my kernel which is active, which is Python 3 IPy kernel. it says it is trusted one, and these are different options which are there again when it comes to this Jupyter notebook. This is to save directly if you want to save a particular checkpoint. So see, it is getting created at the current time. Then plus option to add new cells if you want to add new cells. If you want to cut the cells, you can just use this to cut the cell. The scissor icon is there. If you want to paste cells, so you can paste it. You can, this is to copy, this is to paste. Okay, then you have plus moving this cell up and down. So say I'm writing something A over here, I want to move it up or down. This can be done easily. If I want to run something, if I run it, so see, it is giving me error because A is not defined. Like this is error when it comes to Python. It gives you error if you do something wrong. So we will see the instructions and rules of Python in detail. Then we have this stop option. So suppose I want to stop a running kernel which is hung in between, so I can stop it. I will show you the demo of stop when we are working on loops. So it is a very interesting option you can stop or interrupt a kernel. This option will basically help you to restart the kernel. So if you want to restart the kernel, so we can do it. We will restart the kernel and the kernel is now fresh. Okay, but you can see the output which is there, which it will be there, and you see different options. If you want to restart and rerun the whole notebook, you can use this option. These are shortcuts actually, can be used to kind of write the codes. Then we have this section where we can develop different format of this cell. So this cell can be a code cell, which means it is connected to Python. It can be a markdown. So this is when we create it as a markdown, it is not connected to Python, and that's why whatever you write, it doesn't have, there is no meaning to it for Python. Python actually will ignore whatever you write it. Okay, so it is a markdown. So you can create your markdown so that you can put some notes out there and make it more handy, and like if you want to understand some code, or if you make a note so that in future you can understand it. So markdown is there. You have raw NB convert. This is also not a code section. Python kernel will not understand the markdown also. Then you have heading. If you want to create this as a heading so that in future if you want to just kind of find out important headings, so you can actually work on this. So these are some options when it comes to a normal Jupyter notebook, the entire interface of our Jupyter notebook. So we have discussed the interface of our Jupyter notebook on which we are going to work out. Now we will start a discussion on different rules, instructions which we have to follow if you want to write something on Python. These are very simple rules. Okay, once you get used to these rules, you will become very much efficient at working on it. Okay, so every language has its own grammar, its own set of delivery. Okay, so similarly Python has its own set of grammar. So we'll start with introducing ourselves with different rules. So the first part of any Python program or any Python like writing any Python code starts with variables. Okay, now let's understand what is a variable. Variable is a kind of a construct where we can store some value. Okay, we can store some information into it. So here we are going to start with Python variables first. So like in C languages, we have if you see and compare Python with other languages, they also have variables. Okay, but when we are creating variables in other languages and when we are creating variables in Python, these are completely two different approaches. So if it is a C language, you have to first declare a variable. If it is Java, you have to declare a variable. Now what is declaring a variable? Declaring means you have to specify what this variable is going to store into it. Okay, whether it is going to be a number, whether it is going to be a name, or whether it is going to be a logical true or false value. Okay, so when it comes to variable, it actually has a different approach in both the languages. But when it comes to Python, in Python we do not have that kind of declaration required. Okay, whatever value we are directly passing to it, Python will automatically understand whether it is a integer, whether it is a variable, whether it is a floating, or whether it is a name or anything like that. So we'll try to understand each one of it in detail. So we'll start with understanding the way we create a variable. So as we discussed in the first set of programs that we have seen, we require a operator to create a variable, and that operator actually is equal to operator. So anything you write and you put equal to after it, and if you give some value to it, we are creating a variable. It is very simple. So here we can see in the code, name is equal to Gary, age is equal to 23, salary is equal to something something, marital status is equal to married. Here we are actually creating a variables. We are creating different variables. So there is a variable called as name, there is a variable called as age, there is a variable salary, there is a variable marital status. Now if we talk about each of this variable, the name is all the name of this variable is given by us. We are defining our own variables. The user who is writing code, he can define his own set of variables. So name is a set variable, and you can see it is storing the name Gary. So Gary is an alphabetical data, it is a character data, it is a string data. So by default, name is going to be becoming a string kind of variable. Then age is storing 23. So 23, if you see, it is a number. So age is storing a number, and this number is integer. Okay, when we talk about integer, it is a integer value, whole number, something closer to that. Okay, it is not having any decimals unit. Then you see salary is equal to 25,750. It is again, it is a variable which is storing decimal point number or floating point number. Now what is float? Whenever we have numbers in decimal, we call it as float. So salary is a float, and marital status is married. So marital status is again, it is a string data. So we can store all this information into different variables, and we can use this whenever we require. So this is how we create a variable in Python. So as we discussed this, name is equal to Gary and name is equal to Roger. When we are writing it, we are reassigning variables. So Python facilitates reassigning the variables. Okay, so when I write name is equal to Gary, and if I again write name is equal to Roger, the name will get replaced, the Gary will get replaced with Roger. So this is actually available or kind of there in Python. If I'm reassigning variable, so friend name is equal to name. So if I use friend name, or if I print friend name, it will just show me. I will just show you what exactly is this and how we can create such kind of variable, reassigning variable. Then we have multiple variable. You can create multiple variable as well. Like you can create a variable from other variable also. So for example, Gary age. So Gary age is equal to Roger age is equal to Tom age is equal to 24. So we can assign all these ages as single age 24. So that is also kind of possible when we want to give multiple variable assignment. So you don't have to write multiple lines of code. In a single line you can write Gary age is equal to Roger age is equal to Tom age is equal to 24. That is how a variable is created. We will switch over to variable in Python. We will try to understand how we can create our own variable in Python notebook. So this is my Python notebook, and I want first thing that I will do here is the first line of code I will create it as a heading. Okay, I'm creating it as a heading, and I will write something here. So I will call it as variable. Okay, so this is the heading that I am giving. I will run it, and you can see a heading called as variable is popping up as a heading. Okay, it is a bold and it is huge in size, and we will talk about variables. So I'm creating I'll create some variables. So I'll create a ID variable and ID or identity variable. So identity, say I'm putting some identity number, so I'm putting 10010010001. This is the identity variable. Then I will put first name as the variable. So first name actually can be a string value, so I'll put first name as Vishal. and I can create another variable to put the last name of this person. So last name is equal to, again, say I'm putting Sawant here. As you can see, first name has a string value of Vishal, last name has a string value of Sawant, and say I want to put age equal to, say the age is coming out to be 34 or something, so age is 34, and say I'm putting the salary of this person randomly, and salary, I'll just take a value. Now see here, I have made a mistake, salary, so there is a spelling mistake. It is fine, it is a variable that I am creating. I can call it as salary or whatever I want to give a name, like, it is fine, but I have to make sure when I'm using this salary somewhere, so it has to be in the same name, like the naming convention has to be same, because Python ensures that this variable is actually created. So salary is equal to something, I'll put salary is equal to, say, 96,000, and I'll put some number after this. So this is the salary that he is receiving, 96,000.567, which is the prices that we can see. These are certain variables that I have created. I will say married, whether he is married or not, so I'll say yeah, he's true, he is married. These are some variables that I have created, so let me just run it, and if you run it, you can see these variables are created and there is no error as such. So each variable is created using this equal to sign, and first name is equal to first name is equal to Vishal. We have created it as using this equal to sign. So this is how you can create variables. So when we are creating variables, this is how the approach is for creating a variable. Okay, so if I want to use identity somewhere, I want to show identity to someone, okay, somewhere I'm using it, so I'll call it identity, and I'll just run it. So it is telling me identity is 1001. So because whenever I'm writing identity, it is giving me 1001 because the identity has been created, and I'm writing it. Okay, if I write something else, so suppose I want to write, so I have age, salary, whether is married, say qualification, so I'm writing qualification here. Okay, if I write qualification and if I run print, so it will throw me an error which says that name qualification is not defined. So if you have not defined something, if you have not created something, you cannot use it. So first thing that you have to do is you have to create that variable. Okay, you have to create this variable and give some value to it. Okay, and give some value to it. So qualification is the variable that we have created, and if I want to use it, so I have to first declare it also. So I'll declare it here, qualification, and I'll give qualification as, say, masters in science. Okay, I'm just giving a random qualification to this person, so I'll just run it, and I'll just remove this cell, I don't want it, and I print qualification now. So now only it will give me, because now it has been generated. So you have to make sure that the qualification is generated. One more thing you have to keep in mind, suppose the spelling here, while declaring, I have made mistake in the spelling. Okay, suppose I am creating a new variable called as so these are some details of this person. I will add detail about his occupation or something. So occupation is equal to something, so I'll make a small mistake in occupation. I'll remove this U, and I have created a mistake in the spelling, and I will try to create occupation as engineer or something. And if I run this, it will not throw me any error. See, it is not throwing me any error because occupation is fine. For Python, you can write anything here, it is fine. There are some rules that we have to follow that we will discuss it in a while, but I'm talking about this spelling mistakes. I have made a spelling mistake, but for Python, it is not a mistake. For Python, it will consider, okay, spelling mistake we can ignore. So occupation is fine, but if I want to use occupation here, so I am writing complete occupation, and if I print occupation, it is giving me error that name occupation is not defined at all. Why? Because we have not created occupation, we have created occupation, or a mistake word. So this is a mistake kind of variable. So if you are making mistakes here, so everywhere you create this, you want to use this occupation, you don't have to type occupation as such, you have to type whatever you have created here. So I have created occupation, so I have to use occupation only, I cannot use occupation full word. So make sure that while you are declaring, you make proper words, whatever words that you want to create, you make it correctly, so that you have to create. So this is our print occupation. If I print it now, it is giving me that it is an engineer. So this is variables. Now in variables, we'll talk about certain rules that we need to follow. Every variable, there are certain rules and regulations that we need to follow. So the first rule in creating a variable is that variable name cannot start with a number. It cannot start with a number. Okay, so let us try to create a variable and see if it is allowing me to create a variable starting with a number. So this is a variable name. I want to create a variable named as I want to give another variable identity. Okay, I'm creating this identity for a person Vishal Sawant. I will create another set of variable. So I'm calling it as to identity is equal to, say I'm typing Prashant, and if I'm writing like this and if I run this, see what happens. It is giving me that invalid decimal literal, because I cannot start a variable name with a number. It has to be always alphabet at the beginning. Okay, you can have alphabet at the beginning, you can have numbers at the end. This is not allowed. Identity, to identity is not allowed. So we have to make these changes, and I have to put it as like this: identity 2 is equal to Prashant. So now it will allow me, because variable name cannot start with number. So what I will do is I have created it identity 2 for Prashant, but I will put 2 as here, and I will run it, and I will also write a comment. Now let us start having putting a habit of writing comments also. So comment to explain this error. So error, we are getting syntax error, which is invalid decimal literal. So let us explain this decimal error. So the error is we are getting because variable name cannot start with a number. So I'll just copy with this this rule over here. Okay, so let us call it out as a rule 1. So our rule 1 is kind of violated. The rule 1, basically the variable name cannot start with a number. Okay, so this is the first rule that we are breaking here. Now we'll talk about the second part of this variable. So the second part of the variable rule, or creating a variable, is a variable cannot have, so when you're creating a variable, it cannot have special characters except underscore. So we can have underscores, but we cannot have special characters as our variable. So let's understand. Okay, so we have violated one rule and we have created. So let us create another variable called as say first name. Okay, so first, instead of underscore first name, I'll call it as first name. Instead of underscore, I'll write @ I will give some value as Prashant over here. Okay, so first name @ Prashant. Okay, @ are special characters. So I'll just mention some special characters like exclamation, @ hash, $, percentage. All these special characters I'm just putting, except underscore. All these special characters, there are a lot of different special characters like these. So I'll just skip it. Whatever special characters are there, we cannot use it. So I am using @ just to create a variable first name @. Let's see what happens. And you see that first name is not defined. We are getting an error, that is first name is not defined. Okay, I'll use first name it is not allowing me because first name first name is not defined. So let us use this first underscore name. So I'll call it first underscore name, which is already defined. Let's do it in their own language. Let's do it. So first name, first underscore name @ equal to Prashant. I'll try it and see. Now it is saying that unsupported operand @ equal to. So Python doesn't understand this rule at all. It doesn't allow @ equal to together. Okay, so this is kind of getting violated. So what I will do, I will place this @ in between somewhere. Okay, instead of underscore I will put in between. So first @ name, let's see whether it works out or not. So if you try it, it is not working out because the @ symbol, it is actually not worked out. It is saying that cannot assign to expression here, maybe you meant equal to instead of equal to. So these all errors that we have just seen, these are arising because of the fact that it is not we cannot put a special character in a Python variable. So these are certain rules. So we are kind of violating rule 2. Okay, so I'll put rule 2 here. Whatever the rule was, I've just copied the rule 2 over here, so just to make you understand. If you're working on this Jupyter notebook at your own convenience, you can just refer. Okay, this error, whatever error we were trying to do, it is happening due to so and so error. So this is our second rule which was getting violated when it comes to variable. Now variable name, as we discussed these two errors. So these are errors, this will give you errors. So these are very important rules when it comes to variable. Now variable name can have underscores. We have already created first underscore name, last underscore name, and we can have underscore before also, like it can start with underscore. So underscore first name, if I'm putting, so it can be anything, like as I said Prashant, so I can assign Prashant. So that is actually allowed, underscore first name, which is Prashant. So underscore at the beginning, underscore at the end, it is fine in Python. So this rule is valid. So there is no exception as such when it comes to underscore. You can use it wherever you want when you create a variable. The second part of creating a variable that we need to understand is Python variable or variable are case sensitive. Python variables are actually case sensitive variables. So what is, I don't know why this color, okay, leave it as it is. Python variables are case sensitive in nature. Now what is case sensitivity? So suppose I am creating, say I'm creating a variable a is equal to cat, okay, and I am creating a variable small a which is again small cat, or which is dog. Okay, capital A cat and small a dog, these are two things. Okay, if I do this and if I run a, it will give me cat only, because these are case sensitive. It is not going to allow me to create or it will not reassign the value, because a, capital A and small a are different. So case sensitivity actually works out. So we have to make sure that we are using proper case as well if you want to recall a variable somewhere. So if you have created identity like this, identity whatever it is, and if you are using capital words in identity, it will not work. So capital A and small a are different. If I run a small, it will say it is a dog. If I write a capital, it will say it is a cat. So it is actually case sensitive. That's why we have to follow this rule, that is variable case sensitive. So rule 3 says that it is case sensitive. Variables are case sensitive. Okay, so these are certain rules with respect to Python, and we will explore few more rules. So we have understood what is a rule. We cannot start it with a number. We cannot start with a we cannot include special characters. We cannot have case sensitive, like case sensitivity is also there in Python. So Python is a case sensitive language. Now let's try to understand another rule when it comes to Python. So you cannot use reserved words or keywords. So in Python, if you're trying to use reserved keywords, so that is also not a good thing. We'll try to understand what does this mean actually. So every language has its own set of words. Okay, Python has its own set of keywords. Okay, so we cannot use that reserved keywords. For example, I have a reserved keyword called def. So if I put def is equal to 90, it is saying that def invalid syntax, because def is a keyword used to create a function. So there are certain keywords that you cannot use in Python. If I use is equal to 90, and again if I run this def, I remove this, is equal to 90, again it is not allowed. Def is equal to say 87 is again not allowed. So why? Because these are reserved keywords. These are the keywords which do certain things in Python. These are the keywords which has some meaning in Python. So whichever things has some meaning in Python cannot be used directly as a Python tool. So this is our Python keyword, and here I will just put the violation of rule 4, which means reserved keywords are not allowed. Now there are certain keywords which are not reserved, but these keywords have some meaning. For example, print. So if I talk about print is a function. Print is a function. If I'm writing it like this, and if I put print is equal to 90, so it is allowing me to take the value of print. Okay, print is a function. If I'm assigning print is equal to 90, and it is taking print 90 as the value, but if I run print here, it is giving me the value of print. Even though print is a reserved function in Python, it is allowing me to store the value, but we should not have a practice or not have a habit of using reserved function as a variable. So print is a function where we are assigning 90 as a value. This is a very wrong practice, because there is a meaning to print function. Now if I use print parenthesis, so it says that print is an integer object which is not callable. So here if I am writing print occupation, it is working. As you can see, print occupation. If I run this print occupation here, let me run this print occupation here, see, it will give me error. But earlier it has not given me any error, because print occupation was fine. It was allowing me to print occupation, because print function has an ability to show something as an output. So the use of print function is to show the output. But as I have created print is equal to 90, I have lost that ability and I have created my own version of print. So this word print has a different meaning now. Now if such things are happening, you cannot do anything. You have to simply go to the kernel and you have to clear your output. Okay, restart the kernel and clear your output, because if you do not do it, you will not be able to print again. Okay, so if I'm running this now, see if I can print it again. Okay, so I'll just put all the errors and whatever things we have run. This is fine, this error, because rule 3 is not allowed. And reserved keywords, reserved function must not be used as a variable. Why? Because if you do so, you will lose the Python's potential. So if you do it, you will lose the function's potential. So whatever is the potential of that function, say it is a mean function, average function, a range function, whatever function which is already there in Python, if you are using it as a variable, you are going to lose the use of that function. Basically you are just reassigning your new variable there. So this is how entirely the variable rules are. These are all set of rules when it comes to variable. Now let us talk about reassigning variables. So if you have worked on any programming language, sometimes in certain programming language it is difficult to understand, or it is difficult to reassign the variable. For example, here I am creating a value such as id id1 is equal to, say I am giving id as 201, and it is fine. And if I print this id, print id 1, it is saying it is 201. But if I use id 1 is equal to 301, now my id is going to change. Okay, now my id is going to change, and whatever is the last run statement, it will be considered. So we'll understand a very important concept behind this entire sequence by sequence execution. So Python is a programming language where, say if I have id 1, if I'm placing it like this, okay, which is 201, and if I have id 1 is equal to 301, it doesn't mean that it is going to store both the values. It means that I am creating a variable id1 which is 201, and now I am changing the value of id1 as 301. So if I run this, and you can see that it is calling it as 301, it is not going to consider the previous value. So there is a very important concept. The concept says that Python works in line by line way, which means after the first line, second line, then third line, then fourth line, and it will only consider the current, it will consider all the previous lines, but it will always consider the updated version of your variable, which means it will not use this previous version of variable. If you have recreated this variable again, it will consider this. So these are the some instructions or rules we can talk when it comes to variables. Now let's move ahead in the program. So we have seen variables. Now each variable is storing some kind of information. The information which is stored in each variable can be of different formats. For example, if it is name, it can be number, it can be boolean value, it can be nothing. Okay, so whenever we talk about every variable, any variable, there will be some kind of information into it. So the first type of information that we are going to talk about is string. So string are alphabets or alphabetical values which are usually presented inside a double quotes. Then we have numeric data types, or the information can be a number. So there can be two types of number, one is integer and another one is floating point number. So integer usually is a complete whole number or integer. Floating point number, on the other hand, is a number which will be in the form of a decimal number or decimal value. Then we have boolean. So boolean usually has the data as true or false. So in our case, it will be true or false for Python. And none. None is a data type where we do not have any value or anything assigned to our variable. So variable is just generated which is holding none. Now these are some atomic data types or basic versions of data types. We can also have some advanced versions of data types, which is a collection of all these basic data types. So when we are dealing with collection of data or collection of multiple values together, we are talking about list, we are talking about tuple, dictionary and set. So list is a data which stores the data in contiguous memory location or continuous memory location, where the data which is stored can have multiple values, any kind of value we have. We can have a mix of numbers, we can have alphabets, we can have true or false value, we can have none data type. All these things can be there into a list. We have similar to list another data type, that is tuple. So tuple usually has data, but the problem with tuple is it cannot be changed. Once you have created a tuple, you cannot alter it, you cannot change it. Okay, so tuple usually cannot be altered. That is the only thing. Otherwise it is similar to list. Therefore the operations which are there with respect to list, not all are going to apply to tuple. Then we have dictionary data type. So dictionary is a data type or a kind of a version of data where or a collection of data where the data is stored in the form of key value pairs. So for every key there is a value associated. So for different keys there will be different values. So key value pair, whenever we are dealing with it, it is dictionary. Then we have set. So set is a data type which is storing the data uniquely, which means if there is any data which is repeated multiple times, so set, when it comes to set, we will store only unique identification or unique values into it. We are not going to keep all the versions of the same data, we will just keep the same or one version of the data. So that is a set. We will dive deeper into each of the data types. So when we talk about basic data types, so we are going to talk about string, numeric, boolean, and when it comes to numeric, we talk about integer and float data types. So let us try to understand each of the data types in detail. So creating a alphabet value or string value is very much easy. So strings variables are variables that hold 0 or more characters such as letters, numbers, spaces, comma, and many more. So anything you put inside double quotes can be called out as a string. So name is equal to Charles. So as you can see here, so Charles is an entire string, and the letters inside Charles, basically letters inside the name Charles are each element of a string. Now string is an iterable data type, which means it is made out of combining multiple alphabets together. Okay, it is not a unit entity, it is an iterable. Other hand, we have numeric data types. So numeric data types, we have integer and float. So if anything which is decimal in nature, it is float. If it is numeric in nature or normal integer, normal value without any decimal number, it is a integer data type. Then boolean, as we discussed, boolean it can be only two values, true and false. Okay, so we will try to understand each of the data type in detail, and we will also understand two components of these data type, that is type conversion. So there are two type conversion methodologies, that is implicit type conversion or explicit type conversion. So we will try to understand each of this type conversion in detail. So implicit type conversion is done when Python interpreter does it without programmer's intervention. So without a programmer giving some instruction to Python, it will convert the data into a certain data type. When it comes to explicit data structure or explicit conversion of data types, there the data is forcefully converted to a certain data type. We will see the example of type conversion. So implicit type conversion usually happens when we are doing any arithmetic operation, automatically it gets converted in an arithmetic operation, while explicit conversion happens only while we are doing casting. So we have to typecast a particular data to another type of data. So here is an example of typecasting of a data using implicit conversion. So implicit conversion, you can see sales price, it is a float data type. Number of units, it is again it is integer, and if we are multiplying sales price with number of units, as one is integer and another one is float, so it will give the total price, which is a multiplication of integer and float. It will give us floating point number. So this is an implicit conversion where we have not declared or we have not given any data type to total price. Automatically total price has been converted to float data type. So this is our implicit conversion, and then we have explicit conversion. So in explicit conversion, if we have two types of data types, for example, I have price is equal to 250 and tax is equal to 2.5 as a string. So tax is equal to 2.5 is a string here. We can convert if you want to add price plus tax, because price is number and tax is a string. If you try to add it, it will not allow to add, because it is violating the basic construct, that is it is not able to typecast the data, because it is a string and another one is integer. If one was integer and another one was float, it would have done it, but as we have declared tax is equal to 2.5 as a string, so it is not going to allow us to kind of do the operation. So for that we have to typecast the data. We have to convert tax as floating point number using float function, and then only it will allow us to convert it into floating point number. So we will try to work on the similar lines and try to understand each and every data types in detail. So here again we have to create a markdown. I'll create a markdown and I will call it as data types. So I will divide the data types into two parts. So data types can be divided into, firstly we can call it as atomic data types or basic data types. Atomic, that is basic, some people call it as basic data types. And another one we can call it out as derived data types. We have atomic data types and derived data types. So when we talk about atomic data types, these are data types like integer, float, then we have string. We also have boolean and none data type. We also have one more data type, that is complex number. We will discuss this in detail, what is complex number. So these are certain data types which are atomic in nature, which is unit in nature. So integer is a unit data type, okay. So usually it has whole numbers. Float is a data type which will have decimal value. So the value which is there in a float data type, it is decimal in nature. Then we have string data type. So string is usually in double quotes, alphabetical data or character. Some people call it as characters, alphabets. It can be numbers also, but it can be numbers, but these values are in double quotes. We will see what exactly we are talking about. Double quotes. Okay, we'll see this, what exactly this referred to. And boolean, we have data type as either true or false. So it's pretty straightforward. It will have value true or false with T capital and F capital. None is something which doesn't hold any value, it is missing value. And complex number basically represents a imaginary number, okay. So it is going to show us a imaginary number. So these are our basic data types. Now along with this basic data types, we have some derived data types. So what is derived data type? Derived data types are data types which is usually a collection of data, as we saw in the slide. It is collection of data, and derived data types usually are derived from the atomic data types. So these are the same, like it will use atomic data types to form derived data types, like list of numbers. So list is a data type which is derived data type. So list of numbers, so this is a derived data type. Then we have tuple. So tuple is a data type which cannot be changed at all. It cannot be altered. It cannot be altered or changed once created. Then we have along with list, tuple, we have dictionary. So dictionary is usually key value pair, and after dictionary we also have set as data types. So set which stores unique occurrences. Of data. So we will see each one of it in detail. For now we will focus only on this atomic data types or the basic data types, as we are just going to start with this data types concept, okay. So we'll try to first understand what is atomic data types, and then slowly we'll try to understand all other derived data types as well. So let's start with the atomic data types, that is this one. So we have already created these data types here upwards. So all of the data types we have kind of created, but except few, I will just paste it here. So identity, as you can see, it is 1001. I will just run this also. So this is our identity. Let us see what is the type of identity. Type of identity. So type of identity, it is integer. Then as you can see, it is an integer value that we have assigned, therefore it is integer. Now let's understand type of first name. It is calling out it as string. Okay, so first name is a string. We'll call out type of let's consider age. So age is 34. It is integer. Let's see what is the type of salary. Type of and salary is coming out to be a float data type. And let's see what is type of married. Type of, it is calling as boolean. So type of married is boolean data type. And then qualification, let's understand what is the type of qualification. So type of qualification, okay, qualification spelling is wrong, as you can see. So it's better I will copy the name of the spelling as it is here, paste it here, and you can see it is str or string. Now let's see if qualification is not written like master in size, it is written as 12. Okay, and let's do it. So qualification, the type is, as you can see, it is written as 12, but the number 12 is actually written inside double quotes. So it is considered as floating point number, it is considered as string. Okay, so it is considered as string because it is written inside double quotes. Even if it is a number, it is considered as string only. So if you see the type of qualification, it will be string only. Now I don't want to store qualification as string. Okay, so either I remove double quotes from here, it will become a number, or either I have to explicitly mention or convert it into a number. Okay, so that we will see in the type conversion part. Okay, so before going into that type conversion, let us try to understand the string data types in detail. So this is my string data type S1, and in S1 let me write any normal word. So normal sentence, Python is the most essential element of programming in today's world. So as you can see, Python is the most essential element of programming. This entire value or this entire sentence is actually just a minute. Yeah, this entire sentence is actually a formation of multiple elements. So P, Y, T, H, O, N, and after that we have space also. You can see there is space also. So this entire string is a formation of space, letters, and special characters. Anything you put inside this double quotes, it is a string. If I put some symbols also, programmings or something like that, it is also this special character is also a part of S1. Okay, so you can use double quotes, you can use single quotes. So you can create you can use double quotes, you can use single quotes to create a string. We have used double quotes. I can try to create a single quote. So S2 is equal to let me just put this into double quotes, single quotes. Let's see. I will put entire thing into single quotes. So this entire thing can go inside a single quote. So this entire thing goes inside a single quote. Now if we are talking about putting this into a single quote, this Python is most essential element of programming in today's world. So that can be you can see this entire thing becomes a string. But what if I introduce a single quote inside? If I introduce a single quote, we know that single quote is a part of this string. This is entirely a part of the string. I want to include single quotes as a part of the string. So creating a string with single quotes is not good at all. So we have to convert it into double quotes. So we'll convert it into double quotes. Okay. So Python is the most essential element of programming in today's world. So now I am having this single s or apostrophe s that is allowed now. So using this double quotes we can create. What if I want to use double quotes to specially show something? Say I want to show element as a special thing inside my double quotes. Now if I do this, you can see that this entire thing becomes red, but this element is not becoming red. And if I run this, let me just run it. If I run it, it is giving me error also. In order to run, I am using shift and enter. So if you use shift and enter, you can directly run your command. So Python is the most essential element of programming in today's world. So it is not considering element. So if double quotes, if I want to use double quotes to create a string, or inside a string I want to use double quotes, even a single double quote is not allowed here, because our string is created using double quotes, so that is not allowed. So for that, what I can do is, in order to create the string inside which I want to use a double quote, I can use here triple quotes. I'm using triple quotes, and if I use double triple quotes, so it will allow me to entirely use double quotes as well. So if I'm using double quotes also, so it will allow me. So if I want triple quotes within my string, so I have to put a double quote here, and I have to put a double quote here. So entire thing will become a triple quote. So this is how we can use single quotes and double quotes within a string. Okay, we will be using this in the upcoming slides or tutorials on string data manipulation. So right now we will stop exploring about string, and we will start with integer. As we can see, identity, it is an integer data type. So there is nothing much in integer data type, because it is a single unit value and it is not an iterable. We have already seen what is an integer, and we have also seen what is a float data type, boolean data types. Okay, we have not seen yet a complex data type. So let us consider, a complex variable C1. This is a complex data set, or complex variable of complex data type. So as this variable is complex in nature, it will have two parts. One is real and another one is imaginary. As if you know complex numbers, so complex number starts with the real part, and say if I'm creating a imaginary number 2 plus 3j, so this is my complex number. Okay, now if I talk about C1, it is a complex number with two things, that is real and imaginary, where j basically the value corresponding to j is an imaginary number. So for C1 we can have two things. If I press dot and if I press tab, I will see I will be getting multiple information about it. So if I want only the real part, I can type C1 dot real, it will give me real part. If I want C1 dot, and if I press tab, it is giving me imaginary, I will choose imaginary, and this is imaginary. If I want to get the conjugate of our original complex number C1, so for conjugates we can use C1 dot and conjugate, and it will give me a conjugate number. So 2 minus 3j is a conjugate of our original 2 plus 3j. So this is a conjugate. Conjugate means the imaginary part will become minus. So this is all atomic data types in Python. Now we will talk about type conversion, that is implicit and explicit type conversion. So I'll put it as, and we'll call it out as a markdown. There are multiple shortcuts you can always explore here, whatever you want to create here. Okay, so we have two type conversion methods here, so implicit and explicit. We will try to understand each one of it. Implicit, which is done by, this is a type of conversion which is done by Python itself, okay, automatically, and this is forcefully done by user. Where we forcefully want to convert the data into a certain data type, we can use explicit, and implicit is by default or automatically which is happening. So let's understand both of it. Let's understand implicit first. So in implicit type conversion, suppose I have a value a is equal to 90 and b is equal to 0.45. okay, now if I talk about a, so type of a, I'll just try to print the type of a. It will give me class integer, and if I print the type of b, the type of b, it is becoming float. You can see a is of integer data type and b is of float data type. Okay, so these are two different data types. Okay, now if I add a and b, okay, and store it into c, say c is equal to a plus b. Now c is a new data new variable which doesn't have any data type as of now. As I'm adding a and b together, okay, so these two operations are happening. So the type of a is 90 and type of b is 90, which is an integer, and type of b, which is 45, is float. So when I'm doing a plus b, the combined effect of this data type is going to be of float data type. So if I try to find out the type of c, it is okay, it is not yet declared, and type of c, you can see it is also becoming float. So a is a integer, b is a float, but a plus b is also float because it is trying to retain the maximum data. Okay, it is not converting into float. So this is how we can do implicit typecasting. Implicit typecasting usually happens in arithmetic operation. So implicit typecasting happens in type conversion or basically arithmetic operation. Automatically when you are trying to do some operation, it happens. Whenever the operation is kind of acceptable, whenever the operation is acceptable, say I have a is equal to, or a string, a value 1 which is say 90, and value 2 is equal to say alphabet, or value 2 is equal to Python, say I'm just taking any value. So value 1 is 90, value 2 is Python, and if I use value 1 plus value 2, so, and I'll store it into total or something. So value 1 plus value 2, value 1 is 90, value 2 is Python. If I try to do it, it will not even allow me, because this is a string data type and this is a number or integer data type. So if I'm trying to add these two values, it will not do type conversion because it is also not possible. I cannot convert Python to some number. Okay, so to make it easy, I will just put a number over here. Let me put say 40 here, and now value 1 is an integer and value 2 is a string, and let us try to add these two numbers. So if I try to add this, again it is not working. Why? Because by default in Python, according to Python's rule, it will not allow to add an integer data type with string data type, even if the string data type is a number. So it will not allow to add. So to make it easy, we have to convert this into number, and then only it will allow us to convert or allow us to add. So value 1 is 90, so I have to forcefully convert value 2 as a number. Okay, so right now the type of value 2, so type of value 2 is a string, so I have to forcefully convert it into integer. So in order to do it, how we can convert it into integer is, let me create value 2 is equal to integer of value 2. What I am doing here is I am right now the value 2 is string, okay, it is 40 string, and I am typecasting forcefully and converting this string to integer and assigning it back to value 2. Now the new value 2 is an integer version of value 2. If I run this, and now if I run this, so total you can see it is coming to be 90 plus 40, which is 130. So this is explicit typecasting, where we are forcefully converting a data into a different type. So typecasting is possible explicit only if the data inside value 2 is a number. If it is some other string, say alphabet Python or some Python is written here, again if I try to do it, it will not allow, because Python literal, this is an invalid literal Python, it cannot be converted to number. That is why it has to be converted to number. First it should be a number literal here, it cannot be any alphabet. If you are placing alphabet here and converting it into integer, it will not be allowed by Python. So these are some certain things that we have to keep in mind when it comes to data types or type conversion. So we have seen explicit and implicit typecasting. Now in order to explicitly typecast, we can use integer function, float function, boolean function and string function. You can convert your data into any of the type using any of this function. If you want to convert into boolean, you can use bool and it will get converted to boolean. We will see a very interesting example of boolean type conversion here. So say I have value like this, a is equal to it is written like this, true or capital 2. So I can convert this, so a is capital true and the value or type of a is also string, and I want to convert this as a boolean value. So in order to do that, I can put b is equal to boolean of a. Now if I talk about b, so b is a boolean data type and the value of b is equal to true, like this. So this is how we can convert a value into boolean. Suppose I have value like this, let me take so here I have written true, so I will write false here, false. I will see the type, so a is type of a is false and b is the boolean version of a, okay. So b should be, let's see what should be b. So if I run b, type of b is always boolean, and let's see what is the value of b. So value of b is now true, value of b is now true, but we have mentioned that it is a false value, it is false, but the boolean version of string a is true. The value of a is false as a string, but boolean version of a, the value is true. It is happening because boolean conversion sees that if there is any value present, anything is present, okay. So if you want to make b as false, if you want to hold b as false, you have to put this as an empty string. Let's see, I'll put it as an empty string, b is equal to boolean of a and type of b, and b, now b is equal to false because now there is no value inside a is an empty string. So whenever you have an empty string, then the value of the boolean version of that empty string becomes false. If you have anything written, even if you have written false, it will consider as true only. So this is a very important part of boolean type conversion that we have to keep in mind. Sometimes we skip it, and due to that our most of the programs become wrong. Even if it is an integer value, so this is an example of string type conversion. Let me take a value or number 1 is equal to, say the value is 123. So I will convert boolean version of number 1. So boolean version of number 1, it is true. Similarly here also, if I want to convert it into false, it has to be 0. then only it will become false. If I put -1, let's see what happens if I put -1, it will return true because there is some value there. So if you want to type convert into boolean, you have to make sure that it is returning, is it returning any value or not. If it is returning any value, any value, either it is positive, negative or some kind of characters, it will convert it into true only. It will convert false only if the data is empty or you have value 0. If you have value 0, then only it is going to be false. If you have string empty, then only it is going to be false. Even if you write false, it will not be false, it will be converted into true only. So this is how we can discuss about this. This is how about the type conversion part of your Python data types. So we have seen these examples. So unit price, if it is taken as 52.8, unit price it is taken as 52.8, which is a floating point data type. We can convert this unit price, which is in number format, to string format. It is quite possible. You can simply just convert it into as you can see, say if it is a number 1 which is value 19, you can convert it to string of number 1 and it will give us 19 as a string. Now this is a string 19 which doesn't have a numerical entity. It is not a numerical entity, it is a string entity. So that is also allowed, and you can create this value. Now there is another way of assigning variables here. So you can put like this: number 1 is equal to, so number 1 comma number 2, I can have it as 21 and 0, and if I use type of number 1, it is integer, and if I use type of number 2, it is again integer only, because number 1 is integer, number 2 is integer. You can convert this integer into boolean, you can convert this integer into float. If I convert boolean of number 1, it will be true, and if I convert boolean of number 2, it is going to be false. So these are certain examples of type conversions that we can see. Now we will talk about functions in detail. So before starting with function, let's understand what exactly this entire function terminology referred to. So in Python, usually we are writing codes, and these codes are getting executed one after the other. So the code are going to execute line by line. Python has this very interesting feature that the code actually execute in a systematic line by line approach, and that is the reason it becomes very easy to work on Python. But when we are working on Python, there are instances when the line by line execution doesn't work well, or due to writing the code line by line, we sometimes forgot to do certain tasks, or sometimes it is necessary to repeat the task again and again. So whenever this line by line execution is happening and you want to repeat the same set of code which are earlier repeated again here, so you have to write all the lines of code again in the newer section. So to ease this process out, there is a concept of functions. So in order to minimize the number of lines in a code, function can be utilized. The best part of function is you do not have to write all the codes again and again. Instead of that, you write only once the function, and whenever you want to use this all line of code, you can simply call that function with certain values, certain changes, and it will do the same task as it is expected. So in this class, we will try to understand about functions in detail. So functions basically is a block of reusable code that runs whenever it is called. So as discussed, as we can see, sum function, as you can see, sum function, and there are certain values in the sum function. So if you want to use the sum function, it will definitely help us out to take or add up all the values together. So sum function helps us in adding all the values together, and basically the function should always have a name, and the name of the function is usually the same way in which we have created the variable name, and making sure that function name doesn't use the keyword Python reserved keywords, or it doesn't take the reserved functions which are already created. So that is something that we have to take care of. So that's all in a function. So basically a function has certain set of codes, and whenever you ask that function to do certain tasks, it will do the same set of tasks that you have already defined. Okay, so function has two ways of execution. First is taking input and giving output. So if a function is taking input, so that is called as input parameter. So function whenever takes input, it is an input parameter, and whenever function gives us some output, it is returning by the function, which means function is returning something. So two parts, first is input parameter and second one is returning output. So there are three types of function basically in Python. First is built-in functions, and then we have user-defined functions and lambda functions. So built-in functions are the one which are actually developed by the Python developers. It is already there in the Python environment, like the print function that we have used, input function to take input from the user. There are different functions such as integer, boolean, float, string. These all functions, some of the functions we have already used. So functions are very essential part. So built-in functions serves as a building block of your Python programming language. It eases out all the activity that you want to do when it comes to Python. So we have already used the print function. So print function basically helps us to print a specific message on the screen or throw some output. So message can be a string or any other object, and the Python string function, Python function usually accepts if you want to give your custom message, you have to pass it as a string or you have to pass it as a variable. So it either accepts a string or a variable as an input when it comes to taking input. So when you are using print function, it can print hello world. As you can see, you simply pass a single variable hello world or a single string, or you can pass two strings hello comma Mr. Thomas, and then you can see you can pass multiple parameters also. We can use multiple parameters, single parameters, whatever you want to pass inside a print function. Now print function can also be printed using a separator. For example, if you want to print hello and then Mr. Thomas, so when we are running hello and Mr. Thomas, so it will print hello Thomas together, but if you mention the separator, it will separate these two strings with the help of a comma or whatever separator or special symbol or whatever separator you are mentioning here. It is up to us what we want to add here. By default, the separator is an empty space if you do not mention any separator. If you want a specific separator, you can simply put that separator details here in the sep argument. And if you are printing Python, if you are using print function indistinctly or not correctly, so it will always throw error. We will try to understand Python functions or the print function in detail. So we are talking about print function. So we are starting up with function actually. So I'll create a new function markdown. So in functions, as we discussed, we have three types of functions, that is inbuilt function, then we have user defined function, and then we have lambda functions. Let's talk about inbuilt function, print function. As we discussed, print function. print is a very interesting function if we talk about. So you can see there are multiple star args give us, which means it can accept multiple arguments in a print function. The default separator is given as this separator, and default end parameter is given as new line, file is equal to none, and flush is equal to false. So if you want to see details about a function, you just write the detail print function name, come inside this function argument, and then press shift and tab, so it will give you detail about that function, all the doc string, all the important information about the function. So it becomes very easy to kind of work on using this approach. So say I am printing two values, so I want to print hello world. Okay, so you can see hello world is getting printed. Okay, now hello instead of world I will print something else. So print hello, and here I want to put a random message or a random name or something. So I'll put name is equal to some value, say Akash. So name is equal to Akash. So if I put hello, after hello I'm putting comma, I can put the variable also directly. Whatever is my variable, I can put directly the variable. It can be string, it can be alphabet, whatever, it will automatically print that thing. So hello Akash is getting printed. Sometimes I can put number also here instead of value, like this I can put number, and if I run it, it is printing hello 90. So be it integer, be it float, be it whatever you put, it will print it. If I put true boolean, it will still print it hello true. So print function allows us to print anything, and it converts it to string and prints it out. Okay, now if I want to put print hello and name of some of any of my friends, say Akash, and it will print Akash. And if I want to give any extra thing after this name, so if I want to give some exclamation marks as such, so I can put exclamation mark like this, and it is giving me hello Akash and exclamation mark. So you can pass multiple things, like you can pass any different detail, like enjoy. So if you write hello Akash, enjoy your day, automatically it takes, you can pass in n number of parameters. If I put identity here, it will also print that identity we recently developed, so identity whatever. So if I put first name, also identity first name, you can pass n number of parameters here, there is no limit. Okay, all you have to do is put comma. Okay, so this is entirely how we can write a print statement. Now in the print statement there is an argument called sep. Sep is used to specify how you want to separate the two strings. So hello and name, these are two different entities. So you want to get a hello printed and you want to get name printed, but what you want to put in the empty space between these two, hello and name. So in the empty space we want to put, right now by default it is space, but if you want to put something specifically, say if you want to put two hyphens, so you can put two hyphens. All you have to do is sep is equal to two hyphens, and it will print, see, wherever after every element, after hello you have two hyphens, and then Akash, then two hyphens, then this exclamation, then two hyphens, then enjoy your day, then again two hyphens, then identity, two hyphens. So whatever you specify here, you will get that value. Like anything you can specify, question mark, whatever it is, every time you specify, it will just use the same separator. Okay, so we will also see how we can use print statement with end parameter. So let's say we have a variable hello, and then I am printing something such as world, and after this print statement I am having another print statement where I am saying something else. I am putting a message Python is, and I'll keep this interesting or something. Okay, so if you see there are two print statements, hello and world, and print Python is interesting, something like that. So what if I want to put all these things in a single statement, but I want to use different print statement, or I want to show this as a single output. Okay, so for that I have end. So if I use end is equal to some empty quotes or some space, now these two print statement will act as a single print statement with the separator or ending is equal to space. So here I am using ending is equal to space in order to ensure that after the hello world we do not have a new line, we have directly Python is interesting. So this is one way of writing a print statement, and print is a very useful statement when it comes to Python. It is used very oftenly to print out some output. So that's why print kind of an essential statement. Now we have another statement, this is to show output. Now let us understand another statement, which is to take input. Okay, say I am taking some input value, so for that I have a function called as input, and inside this input function I have to put some message. So I am writing enter a number or something. So when I do this, it will ask me a box, it will create a box and it will ask me some input, and I have to enter anything into it. So I'll put say I'm putting 12. So now whatever I have inserted here, this is actually assigned to the variable val. So if you use type of val to see, or if you see just val, what exactly val is, so val is holding value 12, which is a string value. If you want to confirm, you can simply confirm using val, type of val, and you can see it is a string value. So input function allows us to take input from the user as a string. Okay, but what if I want to use this string as a number? So what we can do is we can do typecasting. So we can do what, val is equal to integer of val. This will convert, like whatever input I have taken, it will convert it into integer type, making sure that the number, the entered value is a number. Okay, so it will convert it into integer, and now val is integer. Okay, you can directly do the typecasting at the type of input. So if you want to do that, you can just put integer here and place everything inside this integer. So whatever is entered by user, it will be first converted to integer and then it will be assigned to val variable. So this is the method of taking input from user, and you can add anything, any number, it will be taken as a number. But if you are not entering, if you are not specifying integer, it will be a string value only. So these are two essential functions in Python when it comes to working on Python code. So Python also supports in print function, we also have this concatenation of strings. So we have already discussed string, so we will discuss about string concatenation. So we will discuss about string concatenation and how we can use it along with the print statement. So we can simply type print and Python and followed by plus sign and is fun. So what we are doing is we are trying to concatenate the string Python with the string as fun. So with this, these two strings are getting concatenated together. Now if I try to concatenate the string Sam's age is with a number, it will not allow me to concatenate because this is a number and this is Sam's age is, it is a string. So concatenating string with a number is not allowed. That's why it will not work. It will throw error such as type error. And if you want to concatenate with typecasting, so you can use it. You have to convert that value, the number, into string first, and then you can concatenate. So this is the way or approach by which you can concatenate the values. So you are concatenating as well as you are doing the typecasting also at the same time in the print statement. Now we will discuss about Python operators in detail. So Python is as we discussed, it is a programming language. So any programming language is used to process information. If you want to process information, you cannot do it without any calculation as such, or without any formation of data. So if you want to do calculation, if you want to form the data in a different ways, so you need operators for that. So Python has a different set of operators. So all different types of operators that you can see in the screen, that is arithmetic operator, then we have relational operator, then we have logical operator, membership operator, bitwise operators, assignment operators, and identity operators. So these are seven different types of operators which can be used in Python to process the data and do some calculation with the data. Now let's understand what is an arithmetic operator. So arithmetic operator has different operators here, like we have addition, we can use plus sign to do addition, then we have minus sign to do subtraction, then we have star symbol for multiplication purpose, we have division symbol for division purpose, then we have modulus operator, it is a percent symbol, and then we have floor division, which is given by 2 backward slashes, and we have exponential with 2 star symbols. So these are arithmetic operations, very much essential for processing arithmetic information or data. So we'll try to implement this arithmetic operator on our Jupyter notebook to process some information. So let's understand the operator plus. So this plus operator is a very interesting operator. I'll call it as arithmetic, or first we will call it as operators in Python. And the first in the first arithmetic we are having arithmetic operator. So we are working on arithmetic operator. I will convert it to markdown. We'll one by one keep on adding each and every operator in this section. So we are talking about the first arithmetic operator, which is plus. So plus operator is used to or I'll just put plus over here. So plus operator is an operator which is allowing us to add data. So it is not just used for adding the data, it is also used for concatenation. So the previous 2 slides in which we have observed concatenation in a print function, we will try to understand it here as well. So first let us understand the plus operator with respect to the values, integer values or float values. So let me have a number n1 which will have value say 100, and n2 which will have value as say 56. So plus operator will allow me to add n1 plus n2, and you can see n1 plus n2 is coming out to be 156. So these values are basically corresponding to the plus operator for addition. So it is adding the values. It is used for addition purpose that we have seen, and along with addition it is also used for string concatenation. So if I'm using print n1 plus n2, if I'm using n1 plus n2, addition of n1 plus n2, it is going to be 156. Okay, now let us now use the similar data, but instead of n1 being as 100, I will put it as string 100, and n2 being as 56, I'll put it as string of 56. And now I will print the addition of string of 100 with string of 56, and let's see what is the difference. So if I run it, so initially when both the things were numbers, you can see the output is 156, which is numeric addition of data, which is 100 plus 56. But when both the things are string, so you can see that it is giving 10056. Okay, so 10056 is the value. So basically here the operation that is happening is concatenation of string, the operation which is happening in the second case, which is the concatenation of string, and in the first case the operation which is happening is of addition or arithmetic addition or mathematical numeric addition operation. So that is the difference between the addition operation. Okay, now the second operator that we are going to talk here is minus sign, minus operator. So as we know that it is used for subtraction purpose, so it is for subtraction purpose. Plus sign was used for concatenation. So let's see how this works. So suppose I'll take the same data, let me take all of this value as it is, let's see what kind of change we can see here. So addition, I'll put subtraction here, and plus, instead of plus I will use minus. So when we run it, you can see the output that we are getting is n1 minus n2, which is 44. n1 plus n2, instead of that I will put minus, and let's see what we are getting. So n1 minus n2 in the first case, when we are considering n1 and n2 as numbers, the value that we are getting is 44. But when I am using n1 which is a string and n2 which is again a string 56, and I am trying to use n1 minus n2 over the string variables, it is returning error because there is no such operator for minus operator for string values. So in string we can only do the plus operation, that is concatenation. It will not allow us to do minus operation. So this we have to keep in mind when it comes to string. So we will get an error here. So error because string doesn't support minus operator. Okay, we cannot do minus in a string. Now we will talk about multiplication operator. Multiplication operator. So for multiplication we use star symbol, and it is simply used for multiplication purpose. And let's try to understand with the same example we will take, and instead of just subtraction I'll put multiplication. Instead of subtraction I will put multiplication. This I will just remove, I'll put multiplication of string n1 into n2, just to see what exactly is happening. So first is n1 which is 100, n2 is 56. These are two numbers. So let's see what is the multiplication of n1 into, okay, it is minus, I will take multiply. So let us see what is the output of n1 into n2. So n1 into n2, n1 is 100 and n2 is 56. So 100 into 56, it is giving the output as 5600. Now considering n1 as string and n2 as string, it is not allowing us to do multiplication, because multiplication can only happen over numbers. These are not numbers, these are values, string values. So let us do one thing, I will use 5 instead of some number, and I will use 5 as a number, and here I will just use any value, that is say 100 or 223, I'll just use 23, and I'm using 5. Initially it is not allowing multiplication between string of 100 and string of 56. That's why we got an error here, because it is not acceptable to multiply strings. Now I have one value as string and another value as number, and let me see what kind of output we can get. So you can see, if one value is a string and another value is a number, so the value string, so here we have 23, so 23 is 23 is kind of multiplied 5 times. So 23 becomes 23, 23, 23, 23, like this it is repeating 5 times in this multiplication operation. So this is how we can do multiplication operation, and multiplication operation can happen only if a number is there with us. So this is a basic introduction of multiplication operator. Now similarly we have division operation. So we'll try to understand division. So n1 divided by n2, and it is very interesting to note what will be the output now. And here also, if I am trying to use 23 divided by say 5, and instead of multiplication I'll put division, I will make this changes here. String gets multiplied 5 times. Now we will talk about division. So here we will see how division performs. So initial n1 and n2 both are numbers. So considering both are numbers, and we will apply the division operation. So n1 divided by n2, we'll see what is the value of division. Then n2 is equal to 23 and n1 is equal to 23, n2 is equal to 5. Both are string. We will run this operation, and you can see the value for first is getting executed. So division value 100 divided by 56 is coming out to be 1.78. But 23 string and divided by 23 5 string is not possible, because there is no option of dividing string values. So what we will do is we will just replace any one value. Let me replace 23 by like 23, let us keep it as it is, and we will keep n2 as 5. Okay, so if I divide it, still it is not allowing, because string and number cannot be divided. It can be multiplied. Multiplication is possible, but division is not possible between string and numbers. So that's the difference between string and multiplication operation. So we have discussed so far plus, then we have discussed minus, we have discussed multiply, we have discussed division, division operator. Now we will discuss exponential operator. So exponential, for that we require 2 stars. So we'll discuss exponential operator, which is 2 stars. Now what is an exponential operator? Exponential operator helps you to get the power of a data. So say the value of n1, I'll just take the same example of data. n1 is 100, or instead of n1 100 I will take 32, and n2 I'll take a smaller number, that is 3 or something. And instead of this divide, I'll use n1 double star n2, and here also I will choose n1 double star n2. I'll consider this as a string to see what kind of value we are getting. I will run it, and initially it is giving n1 to the power n2, which means n1 is 32, 32 to the power 3, which means 32 multiplied by 3 times, it is giving me value 32768. We can verify it here by simply adding a cell, and let us multiply 32 with 32 with 32 and see what we are getting. We are getting the same value, 32768. So we are getting 32 to the power 3, 32768 as the value. But in the second case it is not allowing, because this is a purely mathematical operator. This is a purely mathematical operator to get power of a value. So both the values has to be number. Even if I keep one value as number and another value as a string, it will still not allow. Both the values has to be a number, then only it is allowing me to take exponential values. Both the things are, so 2 to the power 5, it is giving me 32. So in both the cases, exponential operator can only be happening when we have numbers with us, not with string values. Now we will discuss about another operator after exponential, which is integer division. Sometimes we call it as floor division. So integer division operator, and it is denoted by double forward slash. So considering 2 numbers, here in this case also we require both the things as numbers only. We cannot do it for non-numeric values, because it is a division operator, as division operator cannot be performed over non-numeric data. So similarly, exponential as well as integer cannot be happened over non-numeric data. So it is a derivative of division. So if division cannot work over string data, then integer division will also not work over the division of data. So let's work it out. I'll use \/ and I'll call it as integer division. So let's see what we get here. So integer division of 32 divided by 3. So 32 is not divisible by 3. So 32, when I divide it by 3, we are getting the value 10, because 3 tens are 32. If I am using single division, it will give me 10.66, but if I am using double, it will just take the integer part, it will ignore this point, all the values beyond this point. So so the value we are getting here is 10. So this is our integer division of data. Now we will discuss about a very important operator which is used very oftenly in mathematical equations. Also, it is a very interesting operator for people who are applying for interviews and all. That is our modulus operator or percent sign. Modulus operator. So modulus operator is used. This is also an operator only for numeric data types or integer or float data types. And the best part of modulus operator is, if I'm using modulus operator, it will give me only the remainder value. It will give me the remainder. It is used to give remainder value. So if you remember, if you know the division operation, so division operation happens in a way that we have, if a value is divided by something, say if I'm dividing 32 with 3, so 3 ones are 3, and I will get 0 over here, and I have 2 which is getting carried forward. So I will use 3 zeros are 0, and 0 if I do, I get 2, and if I need something I have to put dot here and 3 point. Okay, so if I divide 3 by 32 by 3, so 3 tens are 30 I will get, and remainder will be 2 only. If I divide 3 by 30, 32 by 3, if I divide 32 by 3, the quotient in the arithmetic operation, the quotient value remains 10, and the remainder becomes 2. So here, as we see, remainder is 2. So let's see what is the output after this operator. So I'll keep it as it is. I'll call it as modulus. So as I discussed, it is giving us remainder, not the quotient. If we divide 32 by 3 integer division, it will give me 10. Okay, as we have seen, we are getting 10. Only 10 is the value. So it will stop once the division has happened, and whatever is the remainder, it will just throw it out as the value. So this is how the modulus operator works. And we have covered our arithmetic, all the operators in the arithmetic operators, starting from plus, minus, multiplication, forward slash, which is division, exponential, integer division, as well as modulus operator. Now we will start with another operator, that is relational operator in Python. So in Python there are multiple relational operator to establish relation or kind of have conditional understanding of your data. So sometimes there are instances where we want to change the flow of execution based on conditions. So there we can take help of conditional operators. So these conditional operators or relational operators start with less than, then we have less than equal to, then we have greater than equal to, then we have is equal to operator where we have two equal to signs together, and for not equal to we are having this exclamation mark and equal to combined together. So let us have a quick understanding or demo of this all operators together. So what we will do is we will have A is equal to some value 10 and B equal to some value 5. So and we will see that how these two values are kind of related. Okay, so first operator, as we discussed, it is less than operator. So if we will check that if A is less than B and we will run it, so it is returning false. So we'll call it as a less than operator. So if we run it, it is a less than operator. So A less than B, so I'll put A as it is, comma, less than as it is, followed by again comma. Okay, so 10 less than 5, which is false. So we'll run it. 10 less than 5 is false. So basically 10 is not less than 5, therefore it is returning false. So we will improvise this and we will use greater than operator. So a greater than 5 b, and we'll see that if it is working. So a is the value is 10, is 10 greater than 5, so it is true, therefore it is returning true. So a greater than b, the value that we are getting is an boolean value which is true. Similarly, we have a less than equal to b, and for that less than, and then along with that we can have equal to. A less than equal to b, so this is how we can use it. So if we run it, so 10 less than equal to 5, it is false, so it is not giving any value. Then we have a greater than equal to, let's try it out, greater than equal to. So instead of less than, I will use the greater than symbol. So greater than equal to is if a is greater than 10, or if it is greater than equal to 5. So if a is greater than b, or if a is equal to b, we will return true. So we can see 10 is greater than or equal to 5, which is true, therefore we are getting true over here. Then we have is equal to operator, so we can use is equal to operator also. So a is equal to b, so for that we can use equal to sign, and we can see 10 is equal to 5, which is false. So this is actually returning the correct value. So 10 is not equal to 5, therefore it is returning false. And for not equal to, we will use exclamation mark here and not. So we can see that 10 is not equal to 5 is actually true. So these are all relational operators that we are seeing here. So we are using all relational operators here. So Python supports these all relational operators. Now we will talk about other set of operators, which is logical operators. Now what is a logical operator? So logical operator in Python is basically helping us to compare two relational operators. So when we have two relational operators, we can use logical and, logical or logical not. Okay, so we can see that how the execution goes. Suppose I have x and y. Okay, these are two values, x is a boolean value and y is also a boolean value. This is to compare two boolean operands, two boolean values. So x and y will return true if x as well as y both are true. Okay, so AND operator works only if both the values are true. Okay, now here if you see an example, is student is true, in college is true, and if I use is student and in college, so both the values are true, therefore it will return true. And if is student and in school, so is student is true, in school is false, so these two values are contradicting. So AND operator says that both the values has to be true only. So in this case, one value is true or the other value is false, therefore it will return false. Then on the other hand, we have OR operator. OR operator will return true if any one value is true. So is student is true, in college is true, and in school is false. So OR operator will return true if any of these value is true, so it is returning true. Again, when we use is student and in school, using this OR operator, so one value is true, other value is also false, so one of the value is true, so it will return true. And this is how the execution also works. So if x is equal to true, and if it is yes, it will output will be true. If it is no, it will check y whether it is equal to true or not. If y is true, it will return true. If y is also false or no, it will return false. So this is how logical OR operator works, and NOT operator is simply the opposite of whatever operator value that you are getting. Now we will compare these operators based on certain conditions given here. Okay, so I will take some values. So I will take I'll take both A and B. and here logical operator, I'll paste it here. A is equal to 10, B is equal to 5, and let's say C is equal to 8 and D is equal to say 12. Okay, now we will use logical operator. We have seen a very basic example in the slide, but we will see how we can use logical operator to compare two operators. Okay, so I am saying that if A is less than B, okay, we are using the logical AND operator. So A is less than B, I'll put it inside bracket. If I run this and this, so A is not A is less than B, it is not true. Okay, now I'll use another operator, C less than D, which is true. Okay, so A is less than B, which is not true, therefore it is false. C is less than D, which is true. So both the conditions are kind of contradicting. I will combine both the conditions. So if I combine both the condition, so let me combine it. So I will put it inside A less than B and C less than D. If I do it, it is returning false. As you can see, it is returning false. Why? Because the output of A less than B is false and the output of C less than D is true. If you want to run an AND operator, both the values has to be true. Both sides has to be true in an operator to get true. If you want to get true as a complete outcome, so both the sides has to be true. Okay, now let us take a reverse example. I will change the operator symbol. Here I will take A greater than B, so the output is true. C less than D, which is true, and now I will combine this output here. So A greater than B is true, C less than D, which is again true, and if I run this, it is giving me true. Why? Because A greater than B is also true and C less than D is also true. So both the conditions are true, therefore the final outcome is true. Now let us replace this with OR operator and I will see, let's see what we have. So OR operator, so both the side has to be true in AND operator, but in OR operator, any one side, LHS or RHS, any one side of OR operator has to be true. Okay, so in our case, A greater than B is true, C less than D is also true. So as we have any one value needs to be true, so as any one values has to be true, so it is getting true. Let me change A instead of A greater than B, I will use A less than B, and here also I am using A less than B. Okay, so A less than B is false actually. So A less than B is false and C less than D is true. So when I run it, still it is giving me true, because in OR operator it can give you true if any one value is true. So this is our OR operator. So any one value needs to be true. If I put both the values as false, so A less than B is false and C greater than D is also false. C is 8 and D is 12. So C greater than D is also false. Therefore both the values are false, and as both the values are false, the OR operator will return false. So this is how a very basic logical understanding of AND and OR operator. Now we will understand about NOT operator. Okay, NOT operator, suppose the value of, let's say, E is equal to true. If E is equal to true, so NOT of E is going to be false. If E is equal to false, not of E is going to be true. So not just inverse the value that we are getting. So if we are getting true, it will just convert it to false. If it is getting false, we are converting into true. You can take example of this, A less than B and A greater than B. So A greater than B, if I am running individually, I am getting true. A greater than B, individually it is true, but if I run not of A greater than B, it will return me false. So these are our logical operators, and, or, and not. Now we will talk about identity operator. Identity operator is an interesting operator which is used to compare two values. So it returns true if both variables are stored in same memory location, and it returns true if it is used to check the identities of two variables. Okay, so for that, let us try to understand how this identity concept works. So here there is list 1 with value 10, 20 and 30. There is list 2 with value 10, 20 and 40, and list 3 is nothing but list 1. Okay, and if we check the ID of list 1, list 2, list 3, we are getting list 1 ID and list 3 ID as same, because list 1 is getting assigned the value of list 3 is getting assigned with the value of list 1 only. So IDs of list 1 and list 3 are same. Okay, so we will do one thing, we will compare it on our Jupyter notebook, try to understand how this is operator works. First, let us understand a very basic component of our Python programming, that is identity of a variable. So let me take a variable var1, and the var1 value I will take it as 10, and I will take var2, it is also 10. Okay, so let us now print the IDs of var1. So it is coming out to be this, and I will print the identities of var2 as well. So both are having same identity. Okay, if both the values are having same identity, so the identity is also same, the IDs are also same. These are unique identifiers of variable 1 and variable 2. I will put variable 2 as 10.0, and you can see the first value is an integer and second value is a float. So identities of variable 1 and variable 2 are now different. Now if I use var1 is var2. Okay, so initially I will consider both of them having the same values. I will run it, and as you can see the identities are the same. If I use var1 is var2, I am getting true. But if I change var2 as 10.0, and the identities have become different now, and when I run it, you can see it is returning false. Both the var1 and var2 are holding value 10 only, but first var1 is an integer, therefore it will have a different identity. var2 it is a float, it will have a different identity, and therefore var1 is var2 is actually wrong, it is false. That's why we are getting the value as false. So if you want to negate the output, or if you want to see it in a reverse way, we can use var1 is not var2. Now we are saying that var1 is not var2. So var1 is not var2, basically this is actually true, because var1 is integer 10 and var2 is float 10, and therefore it will return true. So this is our identity operator, and in identity operator we just simply compare the identities of variables. Now we will talk about the membership operator. Now membership operator is used to check the presence of a particular element in an iterable or in a sequence of values. So membership operator is used to see if a particular value is present in list, string, tuple or a dictionary. So let's try it out, the membership operator. This is our identity operator. I'll call it as identity operator. And here we will call it out as membership operator. So membership operator, basically what we are using is in and not in. So say I have a string with value Python and Java are programming languages, okay, and I want to see if a word Python is present inside my iterable. Okay, so for that what I will use word in S, so it is returning true because the word Python is present inside S, Python in S, word in S. So S is Python and Java are programming languages, therefore it is returning true. What if instead of Python I am writing Pythons, and if I check it, it is returning false because I have the word Python, not Pythons. Therefore Python is present, the word Pythons is present inside Python, this entire text or the string variable. Therefore as per the membership operator we have this value. So Python is present and it will return true. So membership operator basically is a simple operator. It checks that if a particular attribute is present inside a sequential order or not. So that's all in membership operator. You have in and not in. If a particular word, say Python A or Pythons, if it is not in, so Pythons is not in this string, but Python is present. So Pythons not in Python and Java programming languages will return true, otherwise it will return false. So let us update all the operator details in our markdown section. So we have seen arithmetic operator, then we have seen relational operator. So in relational operator we have less than, then we have greater than, then we have less than equal to, then we have greater than equal to, then we have not, we have equal to or is equal to operator, and then we have not equal to operator. So these are our relational operators. Then we will talk about after relational operator we have discussed about, let me see which operator we have seen. We have discussed about identity operator and membership operator. So we will talk about identity operator. So identity operator, so identity operators checks that if a particular, so it simply checks the identity of one variable is equal to identity of another variable. Okay, so the operator that we are using is operator. So is, not is, let me just put is and is not. And then we have membership operator that we discuss, in which we will have in and not in operator. So these are all 4 types of operator: arithmetic, relational, identity and membership operator, which are an important component of mathematical formulation of data and kind of operating data in a way that it is processed in a very efficient way. So these are all set of operators that we have seen. Now we will study about some bitwise operators. Bitwise operators are basically used to perform bitwise calculations on integers. We all know that computer is a machine and it will not understand human language or numeric language or whatever instruction we are directly going to pass. The machine will always understand the signal language in the form of binary inputs 0 and 1. And that is why it is necessary that our programming language should be capable of understanding and processing this binary inputs data. So the calculation of binary input data is a bit different from the usual calculations. So here what we are doing is the integers are first converted into binary numbers for whatever operation we are going to apply, and then operations are performed on bit by bit. Now what is a bit? Bit is a singular unit of that particular signal data. Hence the name bitwise operator. Here are few of the bitwise operator that we are having. First operator is bitwise AND. The syntax is given by implicit sign. Then we have bitwise OR, which is given by the pipe operator, bitwise NOT, which is given by tilde operator, bitwise XOR, bitwise right shift, bitwise left shift. So let us try to understand each one of this in detail. So before going into the bitwise operator, we need to understand some basic principle of logical data operations, and the first operation that we are going to discuss here is the bitwise AND operator. Now in bitwise AND operator, what we are doing is we have certain set of data in a form of true and false, and here also we have alternatively true false and true false, and we are going to establish a bitwise AND operation over it. So when we talk about an AND operation, in AND operation both the values needs to be true all the time. If both the values are true, then only the output will be true. So when we applied a bitwise AND over here, so according to the bitwise AND, if first value is true and second value is true, we will get the output as true. If the first value is true and the second value is false, we will get output as false. Similarly, if second value is false and first value is false and second value is true, we get false. And then if both the values are false, so anyhow we are going to get false, because AND operator sees that both the values should be true, then only it will get executed. Similarly, the bitwise OR operator. Bitwise OR operator is similar to AND operator, but it in a reverse way. How? Let us see. So in bitwise OR operator, it will return true if any of the two comparison data is any of the two values is true. So say first value is true and the second value is true, so it will return true. Say if first value is true and the second value is false, so as per the OR operator, we need any one value to be true. So the first value is true, therefore the output is true. Similarly here, the first value is false and the second value is true, so we get the output as true. And if the first value is false and second value is false, so both the values are false, we do not see any signal being flowing, so that's why we call it as false. So it is totally reverse of the AND operator. In AND operator, we need both the values to be true to get true as an output, and in OR operator we need either of the two values as true, so we will get the true as an output. Now we will discuss about bitwise XOR operator. Bitwise XOR operator is used to give you output only if explicitly in single set of data we have true, which means if you have both the side true, it will return false. If you have both the side false, it will return false. If you have only one true in either of the case, then it will return true. So here as we can see, we have true here and we have false here, so that's why we can see the output is true. So it is not similar to OR, it is a bit of different. It is an exceptional OR where it will be operated, it will return true only if one value is true. If both the values are true, it is not going to return true, it is going to return false. So here we see an example of AND operator, how it is executed in our Python program. So say we have a number which is equal to 10, and we say that number modulus 10 is equal to 0. So we know that number modulus 2 will return 0 because the number is 10. So that's why the first condition remains true. this condition remains true, and this is a bitwise AND operator, so that's why we will check the second condition, that is number divisible by 3 equal to 0. So here number is not divisible by 3 because 10 is not divisible by 3, that's why this condition will be false. The first condition is true and the second condition is false. So according to the bitwise AND operator, we see the output, the end output, as false. Similarly, we have an pipe operator. So pipe operator also gives us similar kind of output. So this is a bitwise OR operator. So here we will see that the same output, only thing we are doing is we are changing the AND to OR. Everything remains same and we are getting the output as true, because if you see the first value, the output is true, the second value, the output is false. So according to the bitwise OR, if any of the two condition is true, the output is going to be true. So in our case, the first condition is true and the second condition is false. That's why we are getting true, because it will return true if any of the condition is true. Now we'll try to understand in detail about the binary operations over a data, and see how exactly and what kind of output we are getting. Okay, so first of all, we convert the data into binary. We'll take the binary value of 10 and 12 to see how and what kind of binary value is there for that number, and we will apply some operation over it, and we'll try to see what kind of output we are getting over that binary data. So let's try to do it over Python. So we are going to discuss about the bitwise operator here. So as I told you, say we have a number a is equal to 20 and say b is equal to, or let's take only single number a is equal to 20, and for this number let us apply some binary operation. So I'll say that a modulus 2 equal to 0 if I'm saying, so the output of this particular data is going to be true. Okay, now I'll take another condition, a modulus 3 equal to 0, and I'll see that if a is divisible by 3, so it is false. So we'll try to test it using this AND operator and OR operator. So I'll use AND operator here to see what is the output of a divided by 2 and a divisible by 2 and a divisible by 3. We all know that this is going to be true as it is here, this is going to be false as it is here. So when I run this, the output is false, because as an AND operator it will not return true. As an AND operator returns true only if one value, if both values are true. So AND operator basically returns true if both the values are true. Now we will talk about the OR operator. I'll replace this entirely with OR, or the pipe operator. These are very important operators to combine multiple conditions together when I use this OR operator. So you see that the value we are getting here as an output is true, even though the second value is false, the second condition is false. So according to this pipe operator or OR operator needs at least one condition to be true to get true as an output. So OR operator will return true if either of the two condition is true. And then we have this XOR operator. So XOR operator, let's see, we'll try to test the XOR operator, and it is returning true because any one value is true. Okay, let me do one thing. I will I will, as the first condition is true in this case, that's why it is returning true. So in XOR operator we need at least one operation or one value to be true. We'll try to test it with some one condition. So XOR operator needs only one condition to be true. Let's try to understand the difference. So basically when we talk about the XOR operator, so it requires only one condition to be true. When we talk about OR operator, it requires at least one, which means even if I have more than one condition as true, it will return me the output. So this is how it works. Now we will talk about some external cases or some additional cases with respect to this XOR operator. So say this is our XOR operator and the first condition is true, which is a mod 2 is equal to 0, and the second condition is a mod 3 equal to 0, which is false. I'll replace this and I'll say that a greater than 0. Okay, so if I talk about this condition, if I run it separately somewhere, it will return true because the value of a is 10, so 20, so a is greater than 0, so this condition is true, and this condition we all know that this is already true. So now what I will do is I will run this and we will see that what is the output according to the XOR operator. So according to the XOR operator, it returns false because the first condition is false and the second condition is also false. So it requires either of the two, like it requires only one condition to be true. If both the conditions are true, it will return false. If both the conditions are false, it will return false again. We required only one condition to be true as an XOR operator. Now we know that a is equal to 20 we have taken and b is equal to, say I'll take 12 or something, and we will apply and we'll see what is the value of a and b. So a is equal to 20 and b is equal to 12. I'll print the binary value of a, which is 20. So you can see the binary value of a, you can see 0b basically indicates it is a binary number, and this is the binary value of that number. So there is a different calculation involved for binary operations, so I don't want to get into that calculations. I will just try to understand. This is just a binary representation of a and b. The binary calculation happens with respect to the power or order of 2. So here if I give you a very short intuition of binary operation for say the number a with value 20, so here this is 2 raised to 0 plus 2 raised to 1, so 2 raised to 1, 2 plus 2 raised to 3 and 2 raised to 4. So if I talk about 2 raised to 4, so only 2 raised to 4 and 2 raised to 0, 1, 2, 2 raised to 2 are valid. So 2 raised to 4 plus 2 raised to 2, because other values are 0, so okay. So we see that only 2 raised to 4 the value is there, 2 raised to 3 we do not have, we have 0 here, 2 raised to 2 we have a 1 over there, 2 raised to 1 we have 0, and 2 raised to 0 we have 0. So we can see that clearly there is 2 raised to 4 plus 2 raised to 2. So 2 raised to 4 is equal to 16 and 2 raised to 2 is equal to 4. So 16 plus 4 is equal to 20. This is a basic calculation of the binary number representation, and that's why here we can see 20 as a number, and so 20 basically is correctly represented as a binary output. So this is a basic representation of binary, like any number into binary. We will not get into the much of the binary calculation because that is not the scope of this Python learning. We'll talk about the binary representation of a and b, and we can see that this is how a and b is presented as a binary output. Now we will apply all the bitwise operators over this binary a and b. So I will first apply A and B, and let's see what is the output. So the bitwise operation of A and B is given as 4. So what happens is it takes AND operator over this 4 and it tries to calculate the AND operation. So if I give you a context as such, so 1 0 1 0 0, if it is my number, and if I arrange this number as 0 0 and 1 1 like this, so here we do not have any number, so I'll consider here we do not see any number, so I'll consider 0. So say this is my binary representation of A, this is a binary representation of B, and if I do the calculation as such, so 0 and 0 is going to be 0, 0 and 0 is going to be, this is an AND operator we are going to talk about, 0 and 0 we are going to get 0, 1 and 1, so this is an AND operator, so both the values are 1, that's why I'm getting 1. And similarly here I will get 0 and 0. So if I convert this AND operated value, so this is 2 raised to 0, this is 2 raised to 1, this is 2 raised to 2, and the rest other is 2 raised to 3, and so that is all actually 0. I'll just write it down, 2 raised to 3 and 2 raised to 4, these are zeros, so this will be neglected, this will be neglected, so this also will be neglected, only 2 raised to 2 will be there, which is coming out to be 4, 2 raised to 2, the value is 4. So that's why we call it as a binary operation. So this is an intuition of binary AND operator. We will discuss about the binary OR operator in detail. Now when we talk about this binary OR operator, you can see the value is coming out to be 28, because as we saw the AND operator, it is similar to which we are getting the OR operator, so it will apply the same logic as we are applying over here over the OR operator. Then we can also apply the XOR operator, which is returning the value 28. Basically it is ignoring the places where both the twos are coinciding, so that is why it is going to be less compared to the OR operator. So these are some of the operations in binary bitwise OR operator. We'll try to see some more operators such as tilde or the negation operator or not operator, shift operator also. So let us try to see the bitwise tilde operator and understand it. So say if I am having a value, the output of this particular instance, if it is say false, and if I'm applying a tilde operator over here, and this tilde operator basically converts everything into a negative value, so I'm using this, and if I run it, it is giving me binary -1. Okay, it is used to negate the output of whatever output we are getting. Okay, I'll put it like this, I can put it here also, let's see, and again it is giving me -1, because the bitwise operation when we perform over it, it is going to consider it as negative value, or it is going to negate the value. And along with that we have shift operators. So say A is my number 20, so we'll apply the right shift operator, which is so right shift operator does what if I have the numeric or if I have the binary representation like this, so it is going to shift by 2 units over here. So shift operator helps us to get the value like this. It is going to shift over the right of a binary data or binary value, and we have bitwise shift left shift, so it will shift towards the left, which means it is going to increase the number to by bitwise left shifting. So we'll try to understand what this bitwise shifting actually is. Suppose there is a number like this 1 0 0 0 0 1 0, something like that, and actually the value of this number is something, say 100 or something, or I'll just assume a 1001 or something, some value is there for this number. Now when I shift it towards left, which means I am moving more towards this side, and now I am adding some values over here. Okay, this is my original number, this is the place from original number, so I'll just remove this, just a minute. So when I'm shifting towards left, so it is actually adding some more value over here, the purple ones. When I'm shifting towards right, so it will actually remove this values. So it depends on how much value I'm shifting binarily. So it will take 2 shifts towards the right, 2 shifts towards the left for that original number 20, and the number will change. So it is not like a integer scale, it is a binary scale, and based on this binary scale the values are going to get scaled or shifted. Then there are some more assignment operators which we will be using in Python. These assignment operators are used to assign value in a program. These are used so as to reduce the number of words that we are putting into a code, or kind of easing out the process of writing codes. There is no more significance over it. Okay, so we'll try to understand this operator. So we can see a plus is equal to b. A plus is equal to b basically is similar to a is equal to a plus b. You can write this or you can write this, the output is going to be same. A multiply equal to b, so a is equal to a multiplied by b, so we will get the value same in both the cases. A divided by equal to b, a modulus equal to b, a power equal to b, so a to the power b, and then a integer division of b, we are getting the value. So these are equivalent figures of this code. So if somewhere we are writing a code where we will be getting, or where we will be using this operator, so don't get confused, it is just the same operator. Okay, so we may use it while we are working on codes, and that's how we can use it. Okay, so we'll try to figure it out at the time of execution in a loop or something. Now we will start about a very interesting topic, that is Python flow controls and how Python loop or Python code actually flows. So in order to control the flow of a program, we require certain statements. Okay, be it Java, be it C++, any programming language if we talk about, you need to have a control over the flow of programs. So we all know that Python is a line by line execution language. So when it is a line by line execution language, there are certain instances where we want the flow of the program to get changed, we want the flow of program to alter to some extent. So it depends how we can alter or stop or control the flow of the program. So in order to do that, we will use the Python flow controls. So we have conditional statements to control the flow of the program, we have loops to control the flow of the program, and then we have function calls to control the flow of the programs. So we will talk about the conditional operations or conditional operators here. Conditional operators are very interesting because it will allow us to change the mode of data or flow of data based on a condition. If you do not want to execute the data or certain line of code or certain operation for a certain situation, you can use the conditional operator. It will skip that particular condition, and if the condition is not true, if the condition is false, it will straight away execute the rest of the things if it is false. So we'll talk about the first conditional statement, that is the if block. The if statement is used in Python for decision making. So when we are running a Python code so it is necessary, like if there are certain instances where we will require to change the course of action, so or where we will require some kind of additional input or some statements or something like that, so there we can use the if condition, and if is followed by a condition, and if the condition is true, the statement which is below the if condition will get executed. So let's talk about this if condition in Python. So we are moving to the conditional part. So we are talking about the if condition, and if condition, as I told you, if followed by the condition. Okay, I will take a value of a which was already is equal to 20. So right now it is throwing error. So a is equal to 20, as you can see I'm taking, and I want to execute a code, and I want to see that if a is divisible by 2. Okay, so if I say that if a modulus 2, okay, if this value is equal to 0, which means if a is divisible by 2, if it is divisible by 2, then the remainder is going to be 0. And if this left side of value, if this left side value is equal to 0, and if this 0 compares to this 0, if both the sides are same, which means the condition is true. Okay, in our case right now the condition is true, and I am putting this colons, and after this colons we have to hit enter, and after we hit enter we can print the number is divisible by 2. Let me put the number, I'll just put like this. Let me use a very simple code. So number, the number a is divisible by 2, I'll just print it, and we can see that it is returning some value. So if a modulus 2 equal to 0, which is correct, and that's why it is executing some value. Okay, what if I put a modulus 3 equal to 0? If I do this, let's see what happens. So you can see there is no output, which means it will return true only if a certain condition over here after the if block or after the if statement is true. So immediately whatever you are writing this condition, if it is true, it will return that particular value within the scope of if block. Now understand one thing, unlike other programming languages, Python will not have brackets as such to kind of have the scope of that particular if block. So basically, if this is my if block, this particular space or indentation indicates that this is the block. So whatever if I'm writing, so if I'm writing print a, if I'm writing something else, print say star, whatever I write over here, whatever I write within this if block, so this everything will get executed whenever my condition is true. All of the things within this scope, within this indentation will get executed if my if condition is true.
Enjoyed the session? Don't forget to like, subscribe, and let us know what Python topic you'd like us to cover next.